In this chapter, we are going to learn about the Qt model view architecture, and this is a way we have to separate the way things are displayed from the way things are stored. We're going to see that we will have a bunch of view classes to show or view data, and a bunch of classes we can use to store data, and we will have something in between which is going to control how these two other things, the view and the model, communicate. This is a much broader concept known as the model view controller pattern, but Qt modified this a little bit to put something in between that we call a delegate. And the delegate is going to control how each thing in our model is going to be displayed. I realize this is a bit cryptic at this point, but bear with me. You're going to see how all these things work as we go through the chapter here. We will see how we can display things in lists, tables, or trees. And this is going to be really fun. We will see how we can use some pre-built widgets to do this, and we will see how we can go full scale and set up our own model and view classes to do things in a much more flexible way. Let's head over to the next lecture and do this. In this lecture, we are going to start and look at the model view architecture of Qt. And this is an architecture or an infrastructure that allows us to separate how we store data from how we visualize data. And this is an architecture you will see in other programming languages or technologies. It is usually called the model view controller pattern, and it has three components: the model, the view, and the controller. The model has the job of storing the data or setting up the rules of how data is stored. The view's job is to display data, so it's going to manage the mechanics of how the data is visualized, and the controller is kind of the middleman between the two, allowing communication. For example, if something changes in the model, the controller controls how the view reacts to that, and the reverse is really true. When something happens in the view, the controller is going to manage how that change is going to be handled in the model. So this is really a design pattern that allows for the separation of concerns. Your design is going to be very clean. Some parts of your code are going to be specifically working for storing data, and that's going to be the model. Some parts of your code are going to be mainly working for data visualization, and that's going to be the view part of your application. You will also have the logic between these two things, and that's going to be the controller part of your code. So what we have talked about so far is the model view architecture. So you are asking, Daniel, what do we have on the right here? Well, this is a modification of the model view controller pattern that the Qt framework does to make things work in the way they do. So they really have two parts, the model and the view, but there is something you may compare to the controller that is a delegate. And the delegate is really going to have the job of deciding how each component in the model is displayed in the view. I don't think we will have a chance to really talk about delegates in this course here. If you are interested in this, I would recommend checking our advanced course on Qt, C++ GUI Intermediate. But we are definitely going to talk about models and views. And again, the job is the same. The model is going to store the data, the view is going to visualize data, but Qt is going to give us a host of classes and components we can use to make this work better. I realize some of this may be in the blue right now, especially if you are a beginner to these kinds of things. So bear with me, I am going to give you a bunch of examples. We are going to head to Qt Creator and play with things. And hopefully by the end of the chapter, you will have a really good grasp on how to use the model view architecture in Qt. Okay, so here are a few thoughts I have on models, views, and delegates. Signals from the model inform the view about changes to the data held by the data source. So if something changes in the model has a bunch of signals that it emits to let anyone interested in those signals know. That's really the idea here. Signals from the view provide information about the user's interaction with the items being displayed. So if, for example, you have a list of items and you start selecting, clicking around and doing things, if you do something that should affect your model, the view is going to emit signals that the model could respond to if it wanted. And that's the idea really I am trying to convey here. So the delegate is also the middleman between the view and the model. And signals from the delegate are used during editing to tell the model and view about the state of the editor. So the delegate can be thought of as something that the user interacts with to affect a single item in the model. And the changes may also be affected in the view. For example, if you change the color of an item, that color may be stored in the model, but the view has also to change to display that color. So that's the idea I am really trying to convey here. Now, in Qt, there are a bunch of ways to really work with the model view architecture. The easiest one being using convenience view widgets. In those widgets, data is going to be bundled into the widget, and you won't have to think about the separation between the model and the view and the delegate and things like that. The benefit of this is that you don't have to handle multiple classes. You can do everything in a single class, but that's also a problem because things are not going to be as performant as they should be because you will have different logics bundled into the same class. For example, you have data storage, you have data visualization, you have logic, and that's really bad. I don't recommend doing this. But Qt provides these simple widgets you can use if you have very few items you want to display in your Qt application. For example, suppose you have 10 items you want to display, and that's really not a reason why you would go full scale and implement your own model, plug that into a view, and really do all kinds of crazy things. So if you want to do something simple, you can use these convenience widgets. In these widgets, we have QList widget, we have QTable widget, and we have QTree widget. And we will have a chance to play with all these as we progress in this chapter here. So this is useful when you are trying to show a simple data set and you don't want to go down and deploy all your heavy weapons to really solve a simple problem. It's not suitable for huge, frequently changing data sets. So if you are working with data that satisfies this condition here, you should really think about implementing your own model or even using one of the available models in the Qt framework, as we are going to see. Now, here are a bunch of these pre-built widgets that we just talked about. This is QList widget. This is how it looks. Its main job is to display a list of items. You can see that we have these guys in a list here. We also have QTable widget, which displays a table. You can see we have 2 rows here. You can see we have a bunch of rows and a bunch of columns in here. So this is our table. If you want to display something like a tree, you could use QTree widget. And you see these little plus icons here mean that we can click around and have things expanding. And this is a tree structure you would display within a QTree widget. Now, if you don't want to go simple and use pre-built widgets classes, you can also use pre-built view classes that display the data in the same way. And one thing you should know is that these classes don't have the data bundled in. The data they use is going to be coming from models that we attach to those views. And again, if you don't know how this attaching works, don't worry, we're going to look at that. In this lecture, I am just trying to show you a big picture of the model view architecture in the Qt framework. Here are how these view classes look, and you see they really look similar to the widget classes that we have, but one difference is that the data doesn't live inside these classes. The data is going to be coming from outside components, and these components are going to be models that we could choose to plug to these views to have data displayed in here. That's a really big difference you need to be aware of. Besides view classes, we also have a bunch of model classes that can encapsulate our data. We have models that work like lists. We have models in the form of tables. We also have models in the form of trees. Now, one thing I would like to convey here is that even if we have the capability to work with list and table models, but the way things are represented in the Qt framework ultimately boils down to a tree structure. So for example, you can think of a list as a tree with only one row and each row is not going to have more than one column. So that's an idea you might have. Okay, there are pre-built base models we can base our work on. And if you want to build a list model, a good starting point in Qt is QAbstractListModel. And you are going to subclass this class and build on top of it to have the features you want. We also have the same ideas for tables and trees. QAbstractItemModel is basically used to implement tree models, but we won't talk about that here. Again, if you are interested, do check out our intermediate course on Qt C++ GUI development. If you want to go a bit simple, you can use completely pre-built models like QStringListModels, which is going to give you a list of strings. So it's going to be wrapping around a list of strings. We have a QStandardItemModel we can use to build prototyping models to plug into our views to see how things work. We have QFileSystemModel, we have QSQL Query Model, and the three classes below are going to be used to manipulate SQL-based databases. So if you need to do something like this, these are classes you might check out. And again, at this point, I would recommend you to go in the Qt framework and check out each of these classes to see how they work and try to even figure things out on your own. Now, one good thing I find in the model view architecture of Qt is the flexibility of really choosing how to store your data. And whichever way you choose to store the data is going to be still understood by your views. And this is a good way I found to visualize this. The model is going to be like an interface between different ways to store the data. But the view won't worry about how data is really stored. It will just need to understand the interface provided by the model. So at some point in your application, you can choose to change how you store the data. For example, if you were using XML files to store your data, you can change to store your data in the cloud, and the view doesn't really need to know about that change because it has to talk to one interface, which is the QAbstractItemModel interface we will have a chance to talk about in this course here. Again, you can use databases and all kinds of crazy things, and your data is still going to be displayed the same way without really any change on the part of the view, and this is really cool. Now, before we head off and start playing with models, let's talk about how data is stored. Each model you will have in your C++ program using Qt is going to be based on QAbstractItemModel. So all the convenience models we have are just pre-built things we have, but those things are still based on QAbstractItemModel. Of course, it is also possible to go down and deep and implement your own things using this interface directly. And we will have a simple example on that. I think we will implement a tree model and we will plug that into a view, and that's going to be really cool. So no matter how the items of data are stored in any underlying data structure, all subclasses of QAbstractItemModel represent the data as a hierarchical structure containing tables of items. So what do I mean here? Well, our models are going to be represented like this. We will have an invisible root item, the green thing we have on top here. Let's make sure I can point to it. And it is going to have a bunch of children. So if we are dealing with a list model, things are going to look like this. We will have row 0, row 1, row 2, all the way to the last row. And each row is not going to have more than one column. So we will only have one column in each row. And this is how you would represent a list model. Simple, right? If you start representing things in the form of tables, your models are going to look something like this. We will have a root item, and that root item is going to have one nested table. So we will have a bunch of rows and a bunch of columns as we do here, but each of these things, each of these components we have in this model is not allowed to have children of its own. So we will have one level of children, if I can say it like that. So with this in mind, here are a few thoughts you should keep in mind. Each item in the data structure has a row and a column it belongs to. Again, if we go back, we're going to see that each item is going to have a row and a column. For example, this item here is row 0, column 0, and it's going to be living under the root parent. Okay, so this is the idea here. If we go down to this little guy, we're going to see row 2, column 2, and it's going to be living under the root item. This is really how you should think about items in your model. Okay, each item should also have a parent item. In our case, our parent has always been the root item. And the root item is the top level parent in the entire data structure. I don't think I need to explain this a little more. Items live in a table-like data structure under their assigned parent. And the list-like model data structure is a particular case where the root item has one child table with only one column of data. Again, if we go down like this, we can see that the root parent has one table. Okay, you can think of this thing here as one table, but each row is only going to have one column. And this is really like a table that has a lot of rows, but only one column. And this is going to be our particular case for the list. Now, each item in your Qt models are going to be represented by a class we have in Qt called the QModelIndex, and we will have a chance to talk about this as we progress in the course here. Okay, here is how a tree model should be represented in your Qt application, and I really want you to pay attention to this. If you have to look at one thing in this lecture, I want you to be looking at this figure here. Well, we still have our root item, and our root still has the same child table model, or the same child table, if I can say it like that. But now each child in this table is allowed to have child tables of its own. For example, if we go to the yellow guy here on top, it's going to be a child of the item we have at row 0, column 1, under the root item. Okay? And if we go to row 1, column 1, for example, here, this item, the address of this item is going to be row 1, column 1, under this item, okay, that we have as a child of this root item here. You should really think about this. Again, the idea is the same. The address of each item is going to be decided by its row and column, but also which parent it lives under. Okay, so this is the idea. And your children don't have to be tables. For example, if we go to row 1, column N here, you can see that it has a child list. And this is really a number of rows, and each of those rows is going to have a single column. That's why this guy here is a list. And you can really extend this however you want. I tried to visualize this as much as I can. But think of your models like this. Each item is going to have a row address. It's going to have a column address. But you should also know which parent that item is going to be living under. And if you keep going up, the last parent you're going to meet is the root item, which is really the top thing in your model. And I really want you to keep this super clear in your brain. And in Qt, the row number and the column number and the parent are wrapped by a class that we call QModelIndex. That really encapsulates the address of your item in your model. So each item in your model is going to have a model index, and that model index is going to be wrapping around the row number, the column number, and the parent under which that item lives. Okay, this is another way to look at this, and this is a screenshot from the Qt documentation. So let's look at this here. We have our popular root item by now. And under this root item, we have a child table, which is going to have a bunch of children. For example, A lives in this child table. This thing lives in the child table. All these things here live in the child table. But each item in the first child table can have its own children. For example, you can see A has a child and B is the child of A. And the way we address things in here, you can see we can get the index of A. Okay, and we can ask the model the index of A, and the way we do that, we say, model, please give me the index of something living at row 0, column 0, under the root item. And you get to the root item using this default constructor for QModelIndex. So if you say QModelIndex like this, parents, This is going to give you the root item of whatever model you are trying to work with. Okay, here we have the index A. We can ask for the index of C in the same way. C is going to be living at row 0, 1, 2, column 0, 1. Okay, so row 2, column 1, that's the idea here. And C is still going to be living under the root parent. That's why we use this constructor here. Now, if we want to see the address of B, B is going to be living at row 0, 1 and column 0. So row 1, column 0, but its parent index is going to be the index of A, and this is something you should know here. This is what we are trying to visualize. Really, I would really recommend taking the time to understand this way data is stored in your models, because this will allow you to use models in a much more flexible way. Okay, now that we know about index, we can see how to read data from models. Different types of data can be saved in an item inside a model. For example, we can save the text to show for the item and the background color to show in the user interface. And you specify which kind of data you are looking for in the model by passing in an item data role. And this is specified by this enum here we have in the Qt framework. So if you want to read data, you're going to call the data method on your model, and you're going to tell it, I want to get the data from the item at this index. Again, remember, the index is really the address of the item in your model, and you will specify whatever you want to read from that item using the role here. For example, you can say, I want to get the text of the item, and you will get the text, and we will be using the display role to get the text, if I remember correctly. If you want to get the color, you can say, I want to get the background color of this thing using whatever role gives you that color. And one thing I want you to notice is that the data is going to give us back a variant data type. And if you remember, QVariant is really like a union which has the capability to represent multiple things at the same time. So if we know that we are reading in a string, for example, we might need to call the toString method to get the data that we actually want from the model. Okay, here is an example of how we can use model indexes in the Qt framework. This is a class, I think we will have a chance to talk about this class here. This is a model that wraps around a file system on your operating system, and we can use our model index API to read data from this model, even if what we are representing here is really files and folders on our operating system. And the first thing you do is to get the parent index, and you will get the index pertaining to whatever path you are in your C++ application. And once you have the parent index, you can ask your model, please model, tell me how many rows you have under that parent index. And it is going to give you the row count. And we are going to be looping around here. At each iteration, we will get the index of the item we are at. We will get the row, and at column 0. At this point, we are really supposing that we are looping through a list model because we don't care about the columns here. That's why we have a 0. And once we have the index, we will call the data method, okay, on our model, specifying the index and saying that we want the display role. We want the data we would display in our model, if I can say it like that. Once we have the text, we can do whatever we want with it. For example, we can print it out in the console, or we can even show this in a label or whatever it is we want to do in our Qt application. And one thing I want to say is that this is not the standard way to work with models, and I use this just as an example to show you how you can use the QModelIndex API to do all kinds of crazy things. Okay, we have talked about models, and I think you have now a better idea on this architecture we have in Qt. I apologize, the video turned out to be a bit long, but I really wanted you to give you as much basics as I could in this video. Once you have those basics, we will have a better time trying to use these facilities from the Qt framework. So starting in the next lecture, we will start working with this, and we will start by using the convenience view widgets we have in the Qt framework. We will have a chance to look at QList widget, QTable widget, and QTree widget. Then we will see how we can use pre-built view classes coupled with convenience model classes like QStringListModels and the likes. After that, we will go full scale and build our own model from scratch and see how we can use the QAbstractItemModel API. I am going to stop here in this lecture and I will see you in the next one. In this lecture, we are going to explore the QListWidget class. And this is one of the pre-built convenient widgets that we have to display data in a list. Okay, so it's bundled with data. It's going to allow us to display lists, and it's going to be storing QListWidget items. Now, this is one of the classes we have for the model view architecture in Qt. But the design idea behind this class is to hide all the ugliness of dealing with models yourself. And it's going to be bundling all this logic into a bunch of easy to use methods you can use to add things into the model, for example, to remove things from the model, and all kinds of crazy things you can do with this. But I don't want you to lose sight of the model view architecture side of this class, because it is in there, and I will actually show you that it is possible to read data using something that looks like the data access API from the model view architecture. Okay, so it's going to allow us to do things like this. We will have a list of items, and we will have the capability, for example, to list all the items we have in the model. I am going to show you how to do that. We have the ability to add a bunch of items. We can do all kinds of crazy things. But the main idea here is that the QListWidget class is also going to bring in the data storage logic into the widget itself. And this is something you could use if you want to display simple data lists like we have here. But if you have something complex, I would recommend at least using one of the pre-built models and plug that into a view, as we will see as we progress in the course. But I want you to be aware of the model side of this class here, because it's pretty interesting and you need to know that. Okay, here are a few thoughts about this class. You can read this if you want. I think I have talked about this earlier. And with this class, you can do a few things like adding items, taking items to remove them, getting the count of how many items you have in your QListWidget instance, and things like that. And I would really recommend reading the documentation, and we will do that when we hit Qt Creator in a minute. Now, the class is going to look like this if you put in data. And under the hood, it's going to be using the QAbstractItemModel API. And the idea is that it's going to have a single child under the root item, and that child is going to have one column. So we want to have more than one column in here. That's why this guy is going to be a list. But all this implementation is going to be hidden from us, and we are going to be given a simpler API to use to manipulate these things. So you can think that these things here are going to be hidden, and you will have a clean API, which is QListWidget, to manipulate data and give you the data that you can use on the outside of the class, and that's going to be really cool. Here is how you can read data from your QListWidget. If you have an instance of QListWidget in your code, you can ask it to give you the item at a given index. And these indexes are going to be numbered from 0 all the way to n, n being the number of items in your list. And what you get is going to be a pointer to a QListWidget item, but here I used auto type deduction to simplify things. Once you have the QListWidget item, you can ask that item, give me the data to display using the display role here. But this is not the only role. We have a bunch of roles we can manipulate. For example, we can have display role to get the data that we display, decoration role to see how things are styled. We can get the edit role. We're going to see what this means when we get to build our own models. We can get tooltips. We can really get all kinds of crazy things if we want. And I do encourage you to play with this to see what kind of data you get when you use these roles here. And if I remember, I am going to show you how to do that when we hit Qt Creator in a minute. Okay, now that you know this, I think it is time we headed over to Qt Creator and really put these things together. Here we are in Qt Creator. We are going to create our application. It's going to be a widgets application as usual. We will give it a name and save it somewhere on the drive and hit next. It's going to be a CMake based project as usual. We want to use QWidget as the base. We don't want translation, and we want MinGW as the kit. We don't want Git here, so let's do that and finish. We have the project here generating, but while we wait for this, let's head to the documentation, if I can crack this open. And we will look for a QListWidget. And I want you to do this with me here. So QListWidget, let's look for QListWidget. And if we click to more, we're going to see this is a convenience class that provides a list view, similar to the one supplied by QListView, but with a classic item-based interface for adding and removing items. So this is the interface that simplifies things I was talking about here. QListWidget uses an internal model to manage data. Okay, so again, behind the scene, even if we have a simpler API we can use, behind the scenes, QListWidget is going to be using the model API or the QAbstractItemModel API. This is something I want you to know. You can create a QList widget like this and really manipulate it. You can set the text on a given item and insert this item in your list widget. You can do all these things, and I really do recommend reading the documentation here, coming to the list of available functions here, and really looking at things you can do. This is the best way to learn about this. So let's go back to our project, and we will drag a QList widget component and put that on our form. Let's say list widget. And you see we have two options here if we search for list. And I want you to know the difference. This is a list widget we want to use here, but this is a list view with no model attached. And this is not going to give you data or ways to handle data by default. You will need to set up a model to do that. But with QListWidget, this is going to be coming with the capability to store data. And all you have to do is really put in the data. You don't have to worry about how that data is going to be stored. So let's drag a list widget and put that in here. And remember, this is the design we are after. So we're going to put in two buttons here. Okay, let's go down and put in these buttons. And the first one is going to list the items. And the second one is going to add item. It's going to be adding a single item to our list widget here. So let's give these guys descriptive names. So we are going to go down here and say list items button. And we will do add item button. We want to lay these guys in a vertical layout, and we want to resize this a little bit to make it look nice. I think this is going to do. And now we want to respond when these guys are clicked. So let's add slots here. You already know how to do that. We can go back to the UI form and add item and respond in a slot. Okay, now that we have this, I want you to see that you can even add items from the form. And all you have to do is double click on this. I think we have done this before, but let's make sure we are complete here. So you can say 1 and 2. Okay, you can do that and do OK. And if we build and run, we're going to have two items in our list widget. So if you want the data to be available when your application is compiled, this is one way you can do this to even avoid having code in your Cplusplus CPP files that we have in our project here. Once we have this, for example, we can go to the documentation and look at a bunch of methods that we have. If we go down, you see that we have a count method, and this is going to give us how many items we have in the list. So we can play with this. Let's go to the list items button clicked and print the count. So we can do something like this and include QDebug because we are about to debug output some things. So let's QDebug down here. Count is UI list widget count. Okay, we can do something like this. And if we run and click on this button here, we should see 2 because we have 2 items in the list here. So let's come back here and go to application output and make sure we see our application. If we list items, we see that we have 2 items in the list. Okay, now that we know the count, we can loop through the list, getting the item at each index. And once we have the item, we can ask the data stored inside that item using the data method. Okay, so let's comment this line out. I think we're going to have a better time doing this way. And we will set up a loop that is going to loop as long as I is less than the count of elements we have in our list widget. This is effectively going to loop through all the elements we have in our list widget. And at each iteration, we will call the item method. And I know about this method because I read the documentation. If we go back to the documentation and go to the top, I think we will have an item method. And if we go down, we have an item method. And if you look at this, it's going to return a QListWidget item pointer. And at this point, you must be asking, what is a QListWidget item? Well, why not ask the documentation? And we have an instance of this guy here. You can see right here if it's not visible. So let's double click on this and see what it is. Okay, a QListWidget item represents a single item in a QList widget. Each item can hold several pieces of information and will display them appropriately. What this means is that each item, for example, has a way to store the color of the item. It can store the text that the item is going to display. It can store the tooltip. Let's see if I can show you the tooltip in our application running here. Okay, you see this maximize text that shows up when we hover over this maximize window is a tooltip. And you can put that kind of information in your item if you want, and it is going to show up. And that's going to be governed by the tooltip role, if I remember. So the item view convenience classes use a classic item-based interface rather than a pure model view approach. For a more flexible list view widget, consider using QListView with the standard item model. And you create an instance of this class like this. And I just want you to have the basics of how to work with this. Now, once we have this QListWidget item here, we can call the data method on it and tell it what kind of data we want to get from this item. In this case, we want the display role, which is going to give us the text that is displayed in the item, and that's going to be really cool. And at each iteration, we are going to print the data. So let's see what happens if we run and click on list items here. We're going to hit the green button. This is going to show up, and we will see application output down here. Let's make sure we can see the application. And if we list items, you're going to see that we will have 1 and 2. And this is really cool. Okay, so let's go to the documentation. Let's select on data here and hit F1. And if we go there, you see that we have QItem data role here. If we click on this and show in help mode on top here, we're going to have a bunch of these guys. Okay, and what we want is things we can display in code. For example, the display role is the data to be rendered in the form of text, and it's going to be shown as a QString. Edit role, the data in a form suitable for editing in an editor, and this is also going to be a string. And what else can we do? Tooltip role, the data displayed in the items tooltip. Okay, and we can really play with this. Let's change this to use tooltip role. And to avoid typing this, I am going to copy and go to my code and change this to Qt tooltip role. Let's see if this works. This is going to work. And if we run and open application output and make sure we see our app and list items, you see the tooltip is empty. And if we hover over one of these guys, we're going to see that the tooltip is going to be empty. But what we can do, let's see if we can set the tooltip on the item. Let's try this. We're going to say item ptr set tooltip. Yes, we can do this. And this is really cool. So let's say tooltip. Okay, and we are going to plus QString number I. Let's see how this works out. And what we want is for the tooltip to be tooltip plus the index of the item in this loop that we are doing here. Let's see how this works out. And I do encourage you to play with these things as much as you can. And you see, if we hover over one, let's see if we get our tooltip. And what we have done here is to set up a mechanism to set the tooltips while we are looping through these items here. So if we list for the first time, we're going to see the data here, and this is going to set the tooltip. Once we have clicked Now the tooltips should be available, and you see this is what we have here, and this is really cool. You can do that. If we want the data for the tooltips to be available, even before you click on the button, you can put the code to set tooltips in the constructor of your widget, and that's going to work really well. But now I just wanted you to see that you have different pieces of data you can read from items, and we are using the data API from the QListWidgetItem class, and you really should know that. And please note that here we are just scratching the surface. There is much more to do with models and the QListWidget class. I would recommend, again, to read the documentation to see if you can achieve whatever you are after in your Qt application. And let's do one more thing before we close this lecture off. Let's see how we can add an item, for example. And you see we have a method to add items by passing in a string. This is going to insert the item with text label at the end of the list widget. So this seems like something fun to do. When you add item, we want to grab the list widget and add item, and let's say hello world. Why not? Okay, each time we click on add item, we're going to add an item, and it is going to show up. Let's do that. Okay, we have this guy here. If we click on add item, you see hello world. If we list the data we have, it's going to be looking for tooltips we haven't set. So let's change this back to display role, of course, and clean up a little bit, and we are going to run. Okay, the data is here. We're going to add item. We're going to have hello world. We're going to list. We see the data. If we add item, we're going to have another hello world. If we list, we're going to have a bunch of things here. And this is really all I wanted you to see. Again, don't lose sight of the model side of this. The model is bundled into this widget. It is just hidden from us to give us an easier interface to use if we have simple data sets that we want to display in a list form. But the model is still there. It's just that it is hidden underground to make things easier. This is all I had to share in this lecture. I hope you found it interesting. We will stop here in this one, and I will see you next time. In this lecture, we are going to look at the QTableWidget class, and it allows us to display data in tables. The data is going to be bundled then, just like we did for QListWidget, and it's going to be staring at QTableWidget items. And by this point, you should start seeing that once you really have an understanding of a bunch of classes, the ideas are going to be building on top of each other, and it's going to be easier to understand what is going on under the hood. Again, this is one of the implementations we have for the model view controller architecture in Qt. We have the view, we have the model, and we have the delegate here. The delegate is going to be kind of the middleman between these two guys, and its job is really going to be showing editor widgets in which to apply modifications to the model. So if you type in some text and hit enter, the view is going to show the new data, but the new data is also going to be stored back fast changing huge data sets. If you really have this case here, you should consider separating the way data is stored from the way data is displayed. That's the idea here. We also have a bunch of roles we can play with. We have a Qt display role, Qt edit role, and all kinds of crazy things you see here. Here is how you can read the data from your table widget. This is a method we are going to do in a minute, and it is going to respond when you click on the list items button, and it is going to be looping through every element in the table, getting the data using the data API, and printing the data. This is really simple. So we have two layers. We have rows and columns. We will first loop through rows using the row count method here. Then inside the loop for rows, we're going to be looping through columns we have in each row. This is what we do here. We read the widget item using the item method, and this is going to give us a pointer to QTableWidgetItem. You should remember this, even if we are using auto-type deduction here to make things simple. Once we have the item, we can check to see if it is a valid item. And this is really a safety mechanism. It is possible that we might try to access an item that doesn't exist. And if you happen to call this method on a pair of indexes where no item has been set, you will get a null pointer. And that's why we are doing the check here. So if the pointer is valid, we will read the data from the pointer and we will print the data. Otherwise, we will say that we have no data at that given index. And this is really cool. So this is something we are going to do in a minute. Okay, we will also see how to set data. And this is the code that is going to do that. And the first thing we'll do is to make sure we have enough slots to add data in. And the way we do that, we are going to insert rows and columns. We will insert a new row after the last row. This is how we do it. We insert a new column after the last column. So if we had something like this with 2 rows and 2 columns, and we add a new row and a new column, if we add a new row, we will have something like this, okay, a new row. If we add a new column, that's going to give us a new column, and we will have 3 rows and 3 columns. This is what we are doing here. After we have these new slots in which we could potentially put data, we have 5 new slots we could put data in. We will say we want to create a new item, and we will put in the data hello, and we want this to show up in our table widget, and we will say where we want this to be. So we say row count -1 and column count -1. Remember, at this point, we have 3 rows and 3 columns. So row is going to be 2, column is going to be 2, and we will put this new item in that slot here. So that guy is going to show up in this place, and it is going to say hello. This is something I want you to see, and you can do this if you really want. Now, a question you should ask yourself is, who is going to manage this memory here? Because if you noticed, we created a new memory slot using the new operator here, and we should have a strategy to release this memory. And a good place to look in the Qt documentation is what happens if we set this item to the table widget. It is possible that this table widget is going to take care of managing this memory, but if it isn't managing this memory, you should have your own strategy. And it turns out that Qt is going to manage this memory for us. So let's do QTableWidget. And if we go to the documentation and look for add item, if we go up, we will, oh, it is set item. It's not add item. So let's go to set item. We have row, column, table widget, item, pointer. So this is the guy we are looking for. And if we look here, we're going to see that the table is going to take ownership of this item, and this is something you should know. Now we don't need to worry about releasing this memory we are allocating for here, because this table widget is going to release it when it no longer needs it. Now that you know this, we're going to head over to Qt Creator and do this. Okay, here we are in Qt Creator. Let's create our project. We are going to make it a CMake project, and this is going to be based off QWidget as usual. We don't want any translation. The kit is going to be MinGW for us here, and we are going to be using no git. This is going to generate the project. Let's wait for it to be up and running. It is here, and we are going to do the usual. We want to set up a QList, QTable widget. We don't want QTableView at this moment. And we want a bunch of buttons. I think that's the design we were going for in the slides. So we're going to say list items, and we want to set item. Let's name these buttons here. So list items button and set item button here. And we want to apply a vertical layout to this guy, resize a little bit. And you can also double click here and add things. For example, you can add columns. We're going to have 1 column here. Let's say first call. Okay, for column, you can add another column by hitting the green thing here. Let's say second call. You can go to rows and add things. So first row, and we can add another thing and say second row. Okay, and if we do this, so can we set data? You see, if we go to items here, we have the capability to set data. and we can say 0, 0, for example. I really want you to be familiar with these UI form facilities because they make things better, easier to work with. If you have static data you want to put in your thing, without having to put the data in your C++ code, for example, header files and CPP files, this is going to make things easier. And 2, you can really put whatever you want. So 1, 2, and 3, and 4, and 4. Okay, and if we hit OK and hit the green button here, this is going to compile. If we look at compilation output, and this is going to pop up, and you see it has the data we want. We have headers on the top, we have headers on the left here, and these are things you may want to do. If you don't want these headers, I think, do we have a way to get rid of these headers? Yes, we can take them out. Okay, and they are going to be empty. I don't think we can delete them because we have added these rows and columns. If we do OK, you see the headers are going to go away, and the Qt is smart enough to realize that it's going to take them out. And you can really do all these things if you want, and this is really cool. Now, I just wanted you to see that you could do that from the UI form, but we really want to do this in code, so we are going to delete the rows and columns here. So let's go to rows 2 and delete. Now, if we go to items, we're going to see that it's grayed out and all the data is going to go away. So we want to list items here. And let's make sure we are working on the design. We want, we have these guys here. So let's put the data back pretty fast. I am going to come back once I have the data exactly like this. For headers, for the rows, so on the left we will have 1, 2. On top we will have 1, 2 in numbers. So let's do that. And so let's go in here and add a row. The header for the column is going to have a digit number here, so we're going to put in a 2. And for rows, the headers are going to have 1 in text and a 2 in text. I think this is what we want. And for the data, we want to put in this guy is blue, and this is what we want. Okay, and let's hit OK and see what we get, and this is the design we are after. So let's try to list items. Let's go to slot and respond when this guy is clicked. We can go back to set item and go to slot. We respond when it's clicked. I don't want to type all this code because that's going to waste a lot of your time and my time, and I don't want to do that. But what we are doing here is looping through the rows and columns that we have. We have a 2-dimensional loop here, if I can say it like that. At each iteration in row and column, we're going to get the current table widget item at ij, the current rows and columns in the loop. Once we have the item, and please pay attention to the type here. You see it's going to be deduced as QTableWidgetItem right here, and I know that because if you hover over this, it's going to say this guy is going to be returned as a QTableWidgetItem. You can see that right here, but you can even see this in the documentation if you want. Once we have the item, we're going to ask it, give me the data that pertains to the display role, and that's going to be whatever data this guy can display. If we go to the UI form, that's going to be the data for each cell in the table here. So for the first cell here, it's going to be D. For the second cell is going to be sky. For the third guy is going to be S. For the other cell, it's going to be blue, as you see here. So that's what we are doing, and we are using QDebug to output these guys. Notice that we get the data as a Q variant type, and I really want you to pay attention to this. Some people will get the data and try to print it directly, and what you're going to print is not a string. That's going to be a Q variant, and let's try to do that to really show you how this could go. We are going to build, and if we run, we will have the guys in here. Okay, 1, 2 on the left, 1, 2 on top. If we list and look at application output, we're going to see that what we print are Q variants. And a Q variant is really smart and kind enough to give us this data. Some things won't be this kind and your application may crash or really do something weird. Make sure you are using the data how it is intended to be used. So a good practice is really to turn this to a string. Okay, and we use the toString method here, and this is going to be printed directly without really printing this as a Q variant, and I really want you to be aware of this. Now, let's see this running, and if we list, we should see the data shown here as strings, and this is what we want to show here. Now, let's see how we can set items. If you look at our thing, you see that we have 2 rows and 2 columns. To add new pieces of data, we will need to expand the table here. If you want to add other things, you may need to expand the number of rows that you have. So if you want to target this row, you can say the row number and the column number and really put something in. But what we want is to put something at this slot here. And this will require us to both expand the row number and the column number. Okay, once we have those new slots, these are going to be empty slots with no data. So the data item pointer or the QTableWidget item pointer is going to be pointing to null PTR because we have no data inside. Okay, you should know that. To put in the data, you use the setItem method, and it is now going to be pointing to a QTableWidget item somewhere in memory. That's what we are going to do now. When the set item button is clicked, we are going to expand the table widget. So we are going to insert a row at the end and insert a column at the end of the columns. That's what we are doing here. Again, let's visualize this because it's going to make things a bit easier. Now our table has 2 rows and 2 columns, and insert row at the end is going to insert a new row below here. Okay, now we have 3 rows. Insert column is going to insert a column. But now these new pieces of data or these new slots are going to be empty. They won't have any data, and we can represent that with a bunch of X's. And to put in data, we need to allocate the QTableWidget item pointer on the heap ourselves, put in the data, and then set that pointer at a given row and column. And now we want to set this at column 2 and row 2, this guy here. Now, if we set item, it is going to be pointing to this thing we have on the heap here. I really want you to see this. And again, if you use the new operator, you need to have a memory management strategy. A good thing to do in Qt is to see the table widget where you are setting this thing and see if this method says something about memory management. If it doesn't, you will need to manage this memory. But in this case, we are lucky. As we saw, the table widget is going to take ownership of this item, and we don't have to worry about it ever again in our application here. Let's build and run and see if we can add this new item. We can list the items. We're going to see that the sky is blue. Okay, let's clean up. We can select this and delete. I think we can do that. If we bring this back again and set item, we're going to see now we have hello. Okay, we have hello here. We have 3 rows and 3 columns. But at this point, I want you to know that these guys are not pointing anywhere. The pointers are pointing to null pointer. They are empty. The only thing that has data in here is this guy here. I want you to know that. If we set item again, we're going to add another, and this is the design I was going after. You can put these things diagonally. This is what I was going after. And this is how you can play with these things. This is really all I had to share in this lecture. I hope you found it interesting. We will stop here, and I will see you next time. In this lecture, we are going to look at the QTreeWidget class. And again, this is a convenience widget to show data in tables. And again, my slides are rusty here. So let's do trees and show this again. And the data is bundled then, and it's going to be storing QTreeWidget items. QTreeWidget items. Okay, we have the thing here. We already know most of these things. We are just extending the ideas to QTreeWidget. It's an implementation of the model view architecture, as we know. And what we want to implement here is a tree widget. Okay, so we have the data in here. You see we have a bunch of rows and columns. The headers for the data are showing on top here. In this case, we want to display the ID of an employee, for example, and the name. And the structure I want you to notice here is that at the top level, we have these pieces of data. So we have 1 Snow as the name, we have 2 as the ID, and David as the name. But David has a child item, which is Steve. And Steve is going to show up only if we click on the downward icon here to make it show up. And this is really a tree structure we are going to build here. This is going to be something simple just to show you how you can use the QTreeWidget API. The data is going to be bundled in. This is not suitable for frequently changing huge data sets. And this is only usable when you have simple things you want to show in tree structures. You should know this. And the QTreeWidget can be manipulated from the UI form, but we will be doing things in code in this case here. You can read the data by passing in different roles for the data that you want. You can use display role, edit role, and all the things you see here. This is something we already know from QList and QTableWidget. And here we're going to see something interesting in this lecture, and that's how you add data to your QTreeWidget. And what we do here, we are creating QTreeWidget items on the fly here, and we are parenting them to the tree widget in which they are going to show. This is going to automatically add them to the tree widget component. And I think the tree component is even going to take memory management right at this point on. We will create a new one containing 22 and David. And notice what we do when we create Steve here. We are going to create the component, but we won't parent it to anything, okay? The parent is empty here. And what we do, we give it data to show. After that, we are going to add that as the child of tree item 2 using the statement here. And this is going to make Steve a child of David. This is what we're going to see when we run this program here. And again, you can take some time to read the documentation on QTreeWidget and QTreeWidget item to have even more ideas on things you can do with this. Another thing I want you to see is that when you work with tree widgets, you have to specify the column count. And that's really going to show you how many columns of data you are manipulating within your tree widget. In this case, we are interested in 2 pieces of data. So we have 2 columns here. Here you have a simple example on how you can read data, and we are basically going to taking each item. Okay, we are taking the tree widget in our code. We are asking it how many top level items you have, and it is going to say, oh, I have maybe 2 items here. Okay, but each of these items may have their own children. But at this point here, when we call top level item count on the tree widget, we don't worry about these children as of yet. We worry about direct children of the tree widget, and that's going to give us this guy and this guy here, if this is making any sense. Once we have the top level items, we have the count, we're going to loop through them, getting each one at each index. And once we have the item, we are going to get the data from that item, getting the data at a given column. If you look at the documentation for the data method from QTreeWidget item, you're going to see that it takes in a column and a row. So we pass the row 0 and the row 1 because we have 2 rows in here. We're going to show the data. But we also want to go down and look at the children of each item that we have in this iteration here. So we are going to check the children count. If it is different than 0, we're going to loop around, getting children and printing the data for each child using the same API. So what we do, we are going to go one level down in our parent-child hierarchy in our tree structure, and this is going to give us the data we want. I realize this is really not good to design, but I didn't want to complicate this with recursion or whatever. But please know that there is a way you can really navigate all the inheritance hierarchy, printing all the children in your tree structure. But I won't go that far in this lecture here. Now that you know this, we're going to head over to Qt Creator and play with us. Okay, here we are in Qt Creator. Let's create our project pretty fast. It's going to be a widget application. Let's hit next. It's going to be a CMake project based on Q widget. We don't want any translation, and we want the MinGW kit here. We don't want Git. Let's finish. And as it builds the project, we can look at QTreeWidget. And the QTree widget, we can see that here. And it's a convenience class, blah, blah, blah. You already know these things. You can create it like this. Let's go back to our project, go to the UI form. Here we are going to do things like pros, because you already know quite a lot about using these widgets now. So let's do QTreeWidget. We want the widget here. And this is going to be the only thing we have on this form. So we can click on the form and say vertical layout, and it is going to show up down here. I think it is possible to use the form to add things, but you can explore this on your own. What we are going to do is to go back to the code and go to our widget CPP file and say how many columns our tree widget has. Now we want 2 columns. We say that here, and we specify header data for each of these columns that we have in our tree widget. I think it is possible to do the same from the form. So if we double click here, we can add columns, and at each column, we're going to specify the items here. You can really play with this, but I don't want to go down this path. We're going to do everything in code. I just want you to see that you have choices, and you're going to use whatever you are happy with in your project. Now, once we have this, we will set up a bunch of tree widget items and add them to the tree widget for display. So let's go down and put in the code to do that. We are going to create a QTreeWidget item, give it a name, create it, and parent it to our tree widget. This is going to make it a top level item in our tree widget. And now if we run, we should see 11 Snow, 22 David. Let's see how this looks. Okay, you see the data here, but each of these guys is going to be independent. And some of you are going to say, oh, Daniel, but this looks like a table. How is this different from the table we have done in the last lecture? Well, this component now has the capability to have children. And let me show you how. We are going to come back to the code and create another tree widget item. We're not going to give it a parent, but we are going to add this as a child of tree item 2. So we can do something like this. And see what happens if we run now. So it should be here. But if you look, we have a little arrow pointing right before David here. And what this means is that David has children now. And if we click on this guy, we are going to expand our thing, and we're going to see that now we can have parent-child hierarchies in our tree widget here, and you can do all these things. Now, you can play with this as you want and build your own hierarchies, but at this point, I am interested in showing you that we can read the data we have in our tree widget. And we have the capability to navigate through parent, and we have the capability to navigate from parent to children, reading data as we go down our tree hierarchy, and this is really cool. So how do we do this? I think we need a button to list the data, so let's go down here and do that. Let's list items. We're going to call it list items, and we are going to give it a name, and we want to respond when it is clicked. Go to slot and do this. And what we are going to do is to put in the code, because I don't want to waste your time typing all this. I have this prepared already. So we're going to be getting top level item count. Okay, and we are asking at each level, how many children do you have? Okay, maybe it's going to say I have 3 children. Then you're going to loop through those children, grabbing each of those children and asking each how many children do you have? Then we're going to go down that hierarchy and read the data. This is really what we are doing here. So we are asking the tree widget, how many children do you have? It's going to give us the top level items. We're going to get them. And if we have an item, we're going to print the data. But at each iteration, we're going to ask the child, how many children do you have yourself? And it is going to say, I have 3 children. Then we're going to loop through those children, printing the data. And we are just going one level down in our parent-child hierarchy in our tree widget, if this is making any sense. Now let's go down and run this and see if we can print the data. And one thing I don't want you to lose sight of is that we are using the data method. And if at any point you are confused, you can just click on this method, hit F1 on your machine and go to open in help mode. It is going to tell you whatever this does. It's going to return the value for the items column and row. Okay, and it needs a column number, and we have that in our loops. That's why this thing is going to work, hopefully. So let's see this, and if we list items, we're going to see, we have 11 Snow, 22 David, but Steve is a child of David. That's why we have this representation here that I creatively thought about. This is really all I had to share in this lecture, showing you how you can play with all these convenient widget items. We had a chance to look at QList widget, QTable widget, and QTree widget. And in all these examples, I really tried to call the data method and show you the API we are using to really get the data. And what this really means is that these convenience widgets hide the complexities of models under item-based APIs, as we saw in the documentation. So you will be manipulating items directly. You won't be working with models and items in those models, because that can get complicated. But it is not that complicated if you think about it. We will have a chance to learn about how you build your own models, and you will see that it's really not that bad. So if you need your own model, don't be afraid to build that. You can handle that if you made it this far in the course here. I am going to stop here, and I will see you next time. In this lecture, we are going to start and see how to separate the way data is visualized from the way data is stored. And what is going to visualize our data is a list view, which is a view class that shows things in lists. But the data is not going to be living inside this list view classes. It's going to be living in a separate model. In this case, we will use a pre-built class, which is QStringListModel. And as the name implies, it's going to be wrapping over a list of strings under the QAbstractItemModel API. And that's going to give it the ability to be seen and understood by view classes like QListView. Here are a few thoughts about separating the visualization from the storage. Instead of data being wrapped in the widget class, it's going to be stored in a separate model, and the presentation responsibility is going to fall on view classes. In this case, it's going to be QListView. Okay, we will have 2 parts to our application. The model is going to store the data. The view is going to visualize. This is another way to look at this. And a QStringListModel is going to treat the data in as a model with 1 column, and the number of rows is going to be the same as the number of items in the list. Again, this is an implementation of the model view architecture. We are just going a bit deeper and separating the way things are done. Q widget classes we have seen before wrapped all these things under a single widget. Now, what we are doing is separating these things a little bit. We will have a separate class for a view. We will have a separate class for a model. And the delegate part of the things here is also going to be fallen or swallowed by the view. So we have 2 components here. We have a view class, which is going to play the view role and the delegate role, if I can say it like that. And we will have a separate model class here. This is what we're going to build. We will have a list of items displayed. This looks nothing different from what we have done before. But again, we will have a separate model sitting somewhere in our application. And the model is going to be plugged into this view. And that's going to allow us to see the data here. Here is the code. So what we are going to do, we will create a widget class and we will give it an instance of QStringListModel. And in the constructor of the class, we will initialize the model. Notice that we are giving it a parent, and this is probably going to serve memory management purposes. So we will give it a list to display using the setStringList method, and we will set the model to the view. And when we run the application, the list here is going to magically appear in our list view, and that's going to be really cool. Please remember that the list model is really an implementation of what we have here. We have a bunch of rows under the root, but each row is going to have a single column. So we want to have more items like we have in the table here. Please remember this. We have a root item sitting on top, and we have a bunch of children. Please don't lose sight of this. And here is what we have seen before. Each item in the data structure has a row and a column it belongs to. And the QModel index is going to be representing the address of each item in the model. So for example, if we have the model index for this guy, this is going to say that it is at row 0, column 0 under this root item here. We have said this before, but I just want you to be aware of this every time you work with models, especially now that we are going a bit deep and looking at how models really interact with the views, and this is really cool. Okay, here is a view for when we are working with tree models, but we're not there yet. Here we are just using pre-built models, but again, don't lose sight of this. List and table models are just special cases of the general case we have here, and you need to remember this. And why am I stressing this too much? Because this is going to show up in your APIs. For example, if you need to read something, you need to know the row and column, but you also need to know the parent where that thing is going to live. If we pick this guy, for example, randomly, row 2, column 2, it's going to have a row number, a column number, but it's going to be living under the parent here. And this guy itself is going to have an address, a row number, a column number, and a parent. And we can keep going up until we hit the root item here. Please, please don't lose sight of this. Here is a screenshot from the Qt documentation to really say the same thing. I'm not going to talk about this again. I just want you to be aware of this. And to read the data, we will be using the same roles we have been talking about in convenience widgets. And here we are going to see how we can show the data. And when we click on the show data button, we will get the string list from the list and we can print that. This is one option. But it is also possible to use the low-level QAbstractItemModel API as you see here. And what we do, we're going to ask the model, how many rows do you have under the root item? You see, we are passing QModel index parents here. We are calling the default constructor for QModel index, and this is going to give us a pointer to the root item in our tree structure. Okay, so once we know how many rows we have, we can loop through our items. We know that this is a list, so we won't worry too much about columns. Each column is going to be 0 because we know that each row has 0 columns. Hopefully you understand this. Then we will call the index method on the model to get the model index. We will specify the row number, the column number, and the parent. In this case, it's going to be under the root parent. Once we have the index, we can call the data method, okay, on the model and passing in the index. But it is also possible to get the data by calling the data method on the index. Please take a moment to understand this. Once we have the data, we can print it out and we're going to see it shown on the console. Now that you know this, we can head over to Qt Creator and do this. Here we are in Qt Creator. We will create our project. It's going to be a Qt widgets application as usual. Let's hit next, and it's going to be a CMake project. We want to use QWidget here, the usual thing. Hit next, choose the kit, min.gw is going to be ours here, and we don't want to get let's finish. We can go to the documentation as the project is being generated. We can do QListView to really look at this. So more, and it's going to say list view presents items stored in a model either as a simple non-hierarchical list or as a collection of icons. You see, we have a bunch of icons here. You can play with this if you want. This class is used to provide list and icon views that were previously provided by QListBox and QIconView classes, but using the more flexible approach provided by the model view architecture. The list view class is one of the model view classes, and if you want, and I do recommend to do that, please read the documentation for the model view framework. And if you want an advanced coverage of this, please check out our intermediate course on Qt C++ GUI. You're going to learn about all these things with cool examples you can play with. But for now, we want to do something simple. We have looked at list view, so let's look at QStringListModel. We're going to be using this class as well. QStringListModel, we hit more, and we're going to read about this. This is an editable model that can be used for simple cases where you need to display a number of strings in a view widget, such as QListView or a QCombo box. And here is a simple example. You can do something like this. And another thing you shouldn't really overlook is that you can use a model and pass that into a combo box. And that's something I would challenge you to look at. Ask yourself, how can I display a model in a combo box? Read the documentation for QCombo box to try and figure that out as an exercise. Okay, now that we have covered this, let's go to our project here. We're going to go to the UI form and we will type a list to search. And we don't want list widget. We already know about list widget because this is going to bundle in the model, and that's not what we want here. But now we want a view whose sole responsibility is going to display data, and the data is going to be coming from another part of our application, which is going to be our model. So let's put in our view here, and we want to put in a button that we are going to use to show data. So let's say show data here. And we want to go here and say show data, and go to slot, clicked. That's what we want. Go back to the form, apply a vertical layout, and this is going to do for now. Okay, the data is going to be coming from the model. If you double click on this, you're going to see that the only thing we can change is the object name. So we don't have the ability to change the data like we did for QList widget, for example. This is a notable difference. The data has to come from a model. So what we want to do is to go to widget header and set up an instance of our model, which is going to be referenced by a pointer in our widget object here. So we want to include, first, let's include QStringListModel, and we want to create an instance of that down below here. Once we have this, we can go to the CPP file. We are going to initialize our model, so we can say model equals new QStringListModel, and we want to give this guy a parent. And when everything is done, we want to grab the list view and give it a model using the setModel method, and we want to pass our model here. Now that we have this, we need to set up a string list that is going to be displayed by the view here, and the string is going to be wrapped by the string list model. I know this is a bit convoluted, but this is what we have to work with. So let's say QStringList and say list like this, and we can put in data. So we are going to go down here and put in a bunch of animals: cow, rooster, lion, hyena, and buffalo. And once we have the data in the string list, we can set the data to be shown or managed by our model, if I can say it like that. So let's say model set string list. We have this method here, I believe. Yes, we do. And we pass in our list here. After we do that, we are going to set the model to be shown by our view, and this is going to be pretty cool. So now if we run the application, we should see the list here appear, and it's going to look like the same thing we had with QList widget. But now notice how the data visualization is separated by the data storage in the classes that we are using here. The data is being visualized by a QListView widget, which is using the data it gets from our model, which is a separate component in our application here. And this is really cool. So you can click around and edit and do things, and the model is going to pick up the changes, but we don't have enough details to understand how that works for now. So now we are just going to be happy with displaying the data, and this is really cool. So let's make the show data button here work. We're going to go down here. And before we do, let's include QDebug. I think we're going to need that in a minute. So include QDebug. And we can go down and we are going to ask the list. Now we are going to ask the model, please give us the string list that you are currently managing. And if we do that, we're going to see the data printed out in the string list here. This is something you can do if you are interested. Let's see how this works out. and play with this a little bit. Okay, we have the data here. If we show data, we're going to see the string list. If you want, you can even loop through the list showing each item, if that's the kind of thing you want to do. But what I want to do here is to edit the data in here and see if our model picks up the changes when we show the data. So for example, we can change this to eagle, okay, and hit enter. The data should be in the model now because the model is going to pick up the changes from the view. Let's show the data again, and you see the model has picked this up, and this is really cool. This is magical. I like this. And these are real things you can do, but getting the list from the model and printing that is really not exposing the details I want you to see. So what we want to do here is to comment this out. I just wanted you to see that you can do this, but we want to go down and use the QAbstractItemModel API to show you how views read data from the model under the hood. So I am going to go down and put in a piece of code because I don't want to waste your time watching me type this. What we are going to do is to ask the model, how many items do you have under the root item? And remember, the root item is a thing sitting on top, and we have a bunch of children in here. Each of these children may have its own children, and we can really have nested trees of tables, and that's going to be a bit complicated if you go down there, but this is the basic idea here. We have a bunch of items. Each item is going to have a parent, and each item is going to have a row and a column where it lives. So what we are doing here, we are asking this model, how many rows do you have under the root item? Okay, and it's going to say, for example, I have 3 items. Then we are going to loop for however many row counts we have, asking to get the index at each row. We are not interested in columns again because this is a list, but we will want to read the data. Once we have the index, we can either go through the data method on the index object, or we can call the data method on the model and pass in the index. And I am going to show you that both of these are options and they are going to work. Again, we get the data as Q variant. That's why we are turning this to string. And this may not be obvious, but if you want to see the type deduced by auto here, you can just hover over this and see that you get a Q variant. If we go to the index here and hover over, we're going to see that we get a Q model index, and I want you to be aware of this. Let's run and see what happens when we show the data. Now we are using the low-level QAbstractItemModel API, and I really want you to be aware of this. If we show the data, you see we have cow, rooster, lion, hyena, buffalo. If we edit the data and change this to eagle and hit enter and clean this up so that it doesn't confuse us and bring this back and show the data, you see we can pick this up using this API we are using here, and this is really cool. Now we are reading through the model, but we can ask the index to give us the data it is pointing to, because you can really think of an index as a pointer to data in the model. In this case, we are asking the index, which data are you pointing at? And it's going to give us that data, and this is really cool. Let's run. Before we do, we can clean up and run again. And if we show data, we're going to see buffalo at the end. If we change this and say eagle and show data, we're going to see eagle at the end. Now, some of you must be asking, Daniel, why aren't you passing in a row? Because we know at a given index, we can read data under different roles, and we have seen that in convenience widgets. So what if you want to get a different role here? Well, the answer might lie in reading the documentation, and we want to do that. So let's select data and hit F1. And if we look at this method here, the data method, we're going to see that the role is display role by default. So what we can do is pass in the role explicitly to remove any confusion. So if we call data here, we can pass in the role, and it's going to be the display role. This is going to be the same thing as the default, but I want you to be aware of this. So this is going to show up and do exactly what we were doing before. So if we show data, it's going to say buffalo. If we say eagle and show data, it's going to show data. And this is really cool. This is really all I had to share in this lecture, showing you that we can separate things into view and models. and we took advantage of a pre-built model, which is really simple to show things in lists. And we plugged this model into our view using the line here. We are going to stop here, and I will see you in the next lecture. In this lecture, we are going to learn about QTableView and QStandardItemModel. And we are moving a bit further in our exploration of how you separate views from models and make your things work nice. But this time we want to deal with tabular data structure. So we will be using QTableView, which is a view widget to display things in tables. And we will plug in that into a table model that we will set up in our code here. And we will show things like this. We will also set up a read data method, which is going to read data using the QAbstractItemModel API. And that's going to be really cool. That's going to give you deeper insights into how models work in table mode, if I can say it like that. Okay, we will set up a table view, and it is going to be plugging into a QStandardItemModel we will set up. And now you must be asking the question, what is a standard item model? Well, it is a way we have in Qt to prototype models for quick use. I've never seen this used actually in practice, so it is a good way to test your models. For example, if you want to plug the data into a view and see how the data is going to work, you can set up a simple QStandardItemModel and use that to see how things work. You can use this either in lists, table, and tree models, so the choice is going to be yours. And here is a simple extract I have from the Qt documentation. I do recommend you take a look at this and see how you can really play with this, whether you are dealing with lists, trees, or table models. Now, here is how we are going to use this. We will create an object of the QStandardItemModel class, just like we do here. And we will tell it to have 4 rows and 4 columns. And I know this because I read the documentation. So do yourself a favor and read the documentation for every component you want to use in your Qt application. So we will have 4 rows, and we need 4 rows and 4 columns. So we will have something like this, 4 rows and 4 columns. And once we do this, we will have empty slots without any data. So we will have nothing in here. That's the idea I want to convey here. But we can loop through our table or our table model, if I can say it like that. So we are going to ask our model, how many rows do you have? How many columns do you have? And we will use this information to loop through our model, setting the data at each location in our model, passing in the row address, the column address, and the item that we want to set to that location here. And notice that the item we set is going to be a standard item. And again, take a moment to read about this class. It is an item you can add inside the QStandardItemModel to make things work exactly as you want. Once we have the model, we can display it, and it is going to be shown in our view. This is really nothing complicated at this moment. And this is going to be represented behind the scenes as something like this, because now this is a table model. Okay, this is going to have a root item. Under this root, we will have a table, and each of the elements in this table is not going to have further children, because this is a one-level table, if I can say it like that. So each component is going to have a row and a column, and they are going to be living under the root item. Here is how we are going to be reading data using our QAbstractItemModel API. Again, we will ask the model, how many rows do you have and how many columns do you have? We will loop through the thing, getting data under the parent index or the root index, if I can say it like that. Once we have the index, we can call the data method, or we can call the data method from the model and pass in the index and the display role here as an example. You can really use any role you want, but a display role is the example we are using here. You can see that now this looks strikingly similar to what we did for lists. It is just extended to work with tables, and this is the beauty of the QAbstractItemModel API. Once you really understand how everything plugs together, you won't have any more problems understanding how things are done under the hood. Okay, now that you know this, let's head over to Qt Creator and do this. Here we are in Qt Creator. Let's create our project pretty quick. We will give it a name and save it somewhere on the drive. Hit next. It's a CMake project. We want QWidget as the base. We don't want translations, and binGW is the kit. And we don't want Git as the version control system. And while the project is generating, we can look at the documentation for QTableView. Okay, you can look at this here. Again, it's a view class that you can plug into a model to show the data. And all this is part of the model view architecture of Qt you can read about here. We are going to be using the QStandardItemModel. So let's do that item model here. We want to read about this class. And if we go here, this is a class that can be used as a repository for standard Qt data types. And it is a way to really prototype models. You see here we are prototyping a table model. If you want, you can prototype a tree model. I think that's what we are doing here. You see we have parent items and all kinds of crazy things here. If you want, you can model, list models. You can really do all kinds of crazy things. So take some moment to read at least the detailed description here. Once you are done, we can come back to the UI form and set up a table view. So let's grab a table, and we don't want table widget, we want table view, and we want a button to read the data. Let's do that pretty quick. Read data, and we want to say read the data on the right here in the object properties, and we want to apply a vertical layout and resize this a little bit. And again, if you double click, you see we don't have all the things we had for a QTable widget, because this is not a QTable widget with bundled data for the model. It's just a view class, and it doesn't really know anything about the model. You will tell it about the model it's going to be using explicitly by setting the model to the view, and this is really cool. Let's close out of this and go to read data. Go to slot and apply a method that is going to respond when the button is clicked. We want to go in the header and include the QStandardItemModel because we are about to use that item model. And we want to set up our model as a QStandardItemModel. Let's go to the CPP file in the constructor and initialize this model. And to initialize this model, I am going to steal code from the documentation for a QStandardItemModel. If I go down, you see they are setting up a standard item model, and it looks like what we want. So what we can do is steal the code here and adjust it. And I don't do this out of laziness. I just want you to see that you can steal things from the documentation and use them to your advantage here, and that's a really good thing to do. So let's paste in the code. It's not going to work immediately because we are doing things a bit differently. Our model is going to be pointed to by a pointer here. So we are going to say our model here equals new QStandardItemModel. So we're going to say model equals new QStandardItemModel, and we don't want these guys cramped together. And we want to change all these guys into pointer access operators, and let's go down and do that. And we want to set the item to the model. And now we have the code we had in the slides by stealing from the documentation. So let's go down and set the model to be shown in our table view. We can say UI table view set model, and we will pass our model to be shown. How cool is that? We can build by hitting the hammer button and looking at compilation output. We're going to see things in the process of being built, and we have a problem here. So what is the problem? Issues. Let's look at issues here. And it seems we have a problem with CMake here. I don't really expect this. Okay, let's clean the project and see if this does any good to us. So let's clean and rerun CMake. And if we do this, we say Mark's compilation CPP cannot be placed under this directory. The build may not work correctly. So what is going on here? And it seems the problem may be with the name of the project, which may be longer than expected. So the maximum full path to an object file is 250 characters, and we have more in here. So what can we do? And this is a problem you should know. Paths, long paths can be a problem. So how do we rename this project here? Can we rename it? Let's do, what do we do here? So what I am going to do, this is going to be a hack, but I want to do this live so that you can see this. It may happen to you. I am going to go to the location where I have the project here. So let's go to main.cpp and show in Explorer. This is going to give me the location of the project, and I am going to go there, and I am going to close this project in Qt Creator. So close this project here and go back to my folder again where I have this thing. And I will open this in my editor. Okay, I can do something like this. We are going to get the cmake_list.txt file. And let's say 11.6. We are going to find and replace. Okay, so select this guy and find, Control F, and I want to hit replace in my specific editor here. So if you are using another editor, I am using Notepad++, you may need to find how to change this. So I am going to say 11.6, okay, and say QTableView, okay, use initials here, and QStandardItemModel. Let's replace this, replace all. And every instance of this is going to be replaced. You see that we replaced this in 8 places in our file here. You can see the 8 here if you don't see it. Let's close out of this and we are going to save the file. And I want to go up, okay, and see where this thing was built. And I am going to delete the build directory I had for that. So let's delete that, Shift delete on my Windows machine here. And I am going to try and open that project again in Qt Creator. So let's go to File, Open Project. And I am going to go to Up and go in here. I think I should also rename the folder to avoid any problems. So let's go back there and rename the folder where this thing is, because that may also be the source for the problem. I can take out all the build files here. Let's cancel, okay? And we want to change the name for this to also be what we had in our cmake_list.txt file. So let's do this and copy, and we can close out of this and rename this folder to this. I apologize if this is a bit convoluted, but long file names are not a good thing, and you are seeing that I already have a long list of nested folders here. That's what is causing the problem here, I think. And that's what Qt Creator said, by the way, right here. Okay, you know, the max path is long, so we need to fix this. And this is my attempt at fixing this. So let's open the project and see if this fares better. And I want to open my cmake_list.txt file. If I do open, let's see if the project is loaded. You see the same files we had before, okay? And if I build, let's build and see compilation output. The build is going to be good, and now we are fine. We had to go through a lot of hoops to get this to work, but now it's working. If we run, we should see our table, and woo, this is really cool. You can see that here. Now, let's see how we can read data, and it's going to be really simple. Now that you know how to read data from list models, it's just going to be the same idea extended to table models. Okay, when the read data button is clicked, we are going to loop through the model asking it how many rows do you have and how many columns do you have. At each row and column, we will get the index under the parent. That's what we are doing here. And once we have the index, we can ask the index, please give me your data under the display role. Or we can even ask the model, please give me the data at a given index under the display role. So these are just 2 ways to do the same thing. And I want you to be aware of them. And don't lose sight of that. The data we get is going to be a Q variant. So you will need to turn that into whatever it is you are looking for. In this case, we know that the display role data is going to be a string. So we are turning this to a string. Let's run and show you this in action. Okay, we have the data here. And if we read data, we will see things printed out here. And this is what we expect. You can see row 0, 0, that's what we have right here. Row 0, column 1, that's what we have here. And we can keep going until we hit the end. Row 3, column 3, and that's what we have down here. This is really all I had to share in this lecture. I hope you found it interesting. Please take a moment to make sure how all these indexes and models things we are using here work. We will stop here and I will see you in the next lecture. In this lecture, we are exploring the QTreeView class, and this is a class that allows us to display data in trees, and it is going to be plugged into models that have the capability to also work in tree mode. We don't want to go down and build our own tree model, so we will use some built-in models. One of those is going to be QFileSystemModel, which is going to give you a model that wraps around data on your file system, around things like files and directories, and you can use this to manipulate the data on your file system, and it is something already built into the Qt framework. But I will also show you how you can use the QStandardItemModel API to set up a tree model, and we will steal some code from the Qt documentation, and that's going to be a bit fun. Let's do this. So this is what we want to build. We have a view on the left, and you see this is a tree view because we have a bunch of these downward arrows that we can use to navigate through the tree. You see, this is one of my local directories I am viewing here. And on the right, we have a list view. And the idea I want to convey here is that we can take a single model, for example, a tree model, and feed that to different kinds of views. For example, in here, we are feeding the same model to a tree, and it's going to be shown in a tree mode, if I can say it like that. But if we take that, the same tree model, and feed that to a list view, the view is going to try and do the best it can, and it is going to display a list of data. In this case, it is just listing my drives, and this is a bit interesting to see. You will see how we do this when we hit this in Qt Creator. Now, what we are going to do, we will set up a tree view from the form, but you can also use this in code if you want. And we will set up a bunch of models. We will take a QFileSystemModel and plug that into the view and see how that works. We will take a standard item model and plug that into the tree view and see how this works out here. Again, this is going to be part of the model view architecture of Qt, but now we are going a bit deep to separate how things are done. We have a separate tree view, and we will have a separate tree-like model to store the data that we want to display in our tree view. Now, here is a simple example of how you can set things up. We can set up a path we want our file system model to be wrapping around, and we will set up a dir model, which is going to be wrapping around our file system. This is how you create it by passing in the parent. You can set a bunch of filters to this. For example, you want to only see directories. You can do that right here. But now we want to see everything, directories, files, and everything in the folder. We want the model to be able to store this information and potentially forward it to be shown in a tree view that we attach to this model here. And that's going to be really cool. Now, another thing I want to see is that the same tree model can work on a list view and QTreeView. That's what we do here. You see, we are taking our tree view and telling it to display our dir model, which is really a tree model. But we can also tell the list to display the same model and see what happens. Because of the good design in the QAbstractItemModel API, it doesn't really matter which model you plug into the view. The view knows its capabilities, and it will read as much as it can and ignore whatever it is that doesn't make sense for the view. For example, the list view doesn't really have the capability to manage parents and children, so it is just going to show the first level of the tree model and ignore the rest. And that's what we're going to see here. I am also going to show you that we can use QStandardItemModel, and this is code we are going to steal from the documentation. We will plug this model to be displayed in our tree view, and it is going to work really well. Now, try and take a moment and understand what is going on here. Here we are calling the invisible root item method from our standard item model, and this is going to be our parent item. That's what we do here. Then we're going to be looping from 0 to 4, creating new items, okay? Setting them as children of the root item. That's what we are doing here, and saying parent item equals the current item that we do here. So what this is going to give us is a nested list of items. So we will have something like this, and this is going to have a child, okay? This is going to have its own child, and this is going to have its own child. We will get something like this. This is what we are trying to set up here, to have a tree of things we can show in our tree model. This is really cool. This is going to be the best we can do in terms of models. So this is going to be a full-blown tree model. We will have a root item, and under this root item we can have a table like this, and each item in this table has the capability to have its own children, and you can really go as far and deep as you want. But we're not going to go too far here because that would drive me crazy in this lecture. And here is a method to read the data, and we can either read from our standard model using the data we see here. We get the row count, we get the column count, we can print these things, but we can also get an index by specifying the row, the column, and the parent index. Once we have the index, we can call the data method, or we can even call the data method directly from our model. So you should use whatever you are comfortable with. We already know these things here. Here we are manipulating our dir model, and you can really see that we can use the same kinds of APIs, even if the models we are manipulating here are completely different models. And this is really cool. I can't tell you how happy I was when I was able to understand these things and use them to my advantage in my Qt applications. Now that we know this, we can head over to Qt Creator and do this. Here we are in Qt Creator. Let's create our project here. It's going to be a widget application. We are going to give it a name, and to avoid problems with long file names, I am going to use initials here for QTreeView QFileSystemModel. So this is the meaning here. We can hit next, choose the build system we want to use. We want to use QWidget here. We don't want any translation. We want to use MinGW as the kit, and we don't want Git here. While the project is generating, you can come back to the documentation and look at QTreeView and look at the extended documentation here. So it is a thing you can use to display trees in your applications. You can plug into a file system model to show the data, and you can read all you want about this thing here. We will also be using QFileSystemModel, so please take a moment to read about this QFileSystemModel. It's going to tell you what it is. I'm not going to read that for you. You can see that you can really do all kinds of crazy things. For example, you can make directories, you can remove directories with this model. This is really cool. Let's go to the UI form and look for tree view. Okay, we're going to drag and drop this, and we want a button to read data. This must be becoming second nature now to you. Read data, and we want to say read data button. I think this is going to do. And we want to apply a vertical layout and resize this a little bit. And again, as we have done, if you double click, you're not going to have a way to really manipulate the model data because the data doesn't live in the view. Now we are separating the way we store data from the way we read data. But now we want to do these things for trees. We are basically going to do the same thing we did for a QListView and QTableView, but extend the idea to QTreeView. Don't lose sight of that. Okay, we have this here, and I think we can respond to the slot from the button. Okay, now that we have this, we can head over to the header file and put in our models. But before we do, let's include here, so QFileSystemModel. We want to use this and include QStandardItemModel. We want this, and I will put in a bunch of pointers here. Okay, and I think we need to change the UI form. According to the design we have here, we want to have a tree view on the left and a list view to the right, so that I can show you that you can plug the same model into different views, and that's going to be very cool to see. Let's do this. We are going to go to the UI form and break the layout a little bit. So let's break this, and we want to go down and look for list view. We want to put that next to our thing, but make sure you know the difference. The left thing is a tree view, as you can see right here. The right thing is this a tree view? It's a list view, as you can see right here. Okay, let's apply a horizontal layout to these two. So horizontal layout, and apply a vertical layout to the thing. Now we can have our user interface that we want. We can go in our widget CPP file and initialize these models. Now, we are going to start with our file system model, and we will say dir model. And let's rename this to dir model to be consistent here. Sorry for this. I think Qt Creator is now going to be happy. So we are creating a new model, and we are using our pointer to point to it. And we can set a filter. I don't think this needs much explaining here. You can just specify if you want to see directories or files or the things that represent the current directory and our parent directory. This is what it referred to. Oh, we don't want to see them, but you can really click on the documentation here and hit F1 and read what is going on with these enums that we have in Qt. I'm not going to do that because I really want you to be able to do things on your own. Now, the same data we have in our model can be shown either in a tree view and a list view. And that's something I really want you to see. Now we have a model. We didn't really have to do much because this model is now going to be trying to view my drive, and it's going to show you data at this level. But in a tree view, we're going to see that we can navigate through children and parents, but we can't do that in our list view. Let's run and show you that. It's easier shown than talked about, I think. And let's wait for this to come up. And you see on the left, we have something a bit fun. Okay, you see we have a tree view on the left. You see we have a bunch of things because the tree view has the capability to manage columns. Let's maximize this so that we really see everything. Okay, I think that's going to be much better. We have 4 columns by default. And if we go in E, for example, we have the capability to navigate through my file system here. And this is really cool. And now one thing I want you to see is that we have a thing displayed as a tree on the left, but it is displayed as a list on the right because on the right we have a list. For example, the list view doesn't have the capability to display all these columns. It doesn't have the capability to allow us to navigate through parent folders and children. So that's the difference you have here. But one thing you should notice is that you should design your models. That is, if you get to the point of designing your own models with the idea that they could be used on views where you don't intend them to be used. That's the choice the Qt company did with these models. And it is really interesting to be able to plug a tree model into a list view and still get something working. This is really amazing here. So let's close this, and we will try and do the same using a standard item model. So we will set up a standard item model and plug that into the tree view here, just to show you that you can really do that. Let's try and comment this out. So what we can do here is get rid of these block comments because we want a nice block comment around everything here so that we can really turn on or turn off which section we want. So we can do something like this and say that we are using QFileSystemModel, QFileSystemModel. And now we want to use QStandardItemModel to set up a tree model that we can show in our tree view and list view. We're going to try and do that. So I am going to put in the code here to save on typing, but I want you to see that this is code I stole from the Qt documentation, just to show you that you can do that. So let's go back to QStandardItemModel. We want that, and if we go in the examples, they show you how you can set up a tree model. This is the code we are stealing here, and adapting that to work with our tree view and list view here. Even do that, we can say UI list view and set model and pass in our standard and put our semicolon. And if we try to build, let's see what happens. Okay, the build is good, we can run. And now, remember the tree structure we set up. Okay, each item is going to be parented under the previous item. You can look at the code to understand that. Notice that we can really navigate through these guys. Again, see what the list is doing. The list can only handle one level of children, if I can say it like that. So it is going to display the first root level item, if I can say it like that. And it doesn't have the capability to navigate trees like the tree view does. So it is going to show item 0 here. And this is going to work. So now that we know this, we can see how to read data, and we are going to be responding in this method here. I think we can turn this back to work on the file system model. And then we are going to come back here when we need to. So let's do that. And this is going to be working on QFileSystemModel. Let's say that in a comment. No, this is a QStandardItemModel. Model in tree mode. This is what we are doing here. We want to re-enable by the code that uses QFileSystemModel to show you that you can read data. Okay, so what we are going to do is read from the file system model, and we will put in the code to do that without really wasting your time. You can read this. So we can get however rows we have, how many columns by passing in the root index. That's what we are doing here. And once we have the index, we can get the index, for example, for the first element by saying we want the element at row 0, column 0 under the root item. And what this is going to do is really grab an item like this. So row 0, column 0 under the root item. Once we have the index, that's what we're going to get from the index method here. We can call the data method. We are using a default role here. So this is going to be the display role, and we will print the data. So this is going to be our dir model. Remember that. So let's run and see what's going to be printed when we read. Okay. So try to think about what we're going to get if we print here. I am going to try and expand this as much as I can so that you see things happening. So what do you expect to see printed if we click on read data here by looking at the code we have below here? Try and guess before you hit this button here. After you know your guess, open the application output pane and hit the read data button. Okay, we're going to get row count, column count, and notice what we get for the data at row 0, column 0 under the root item. That's going to be the first thing here. And this is really magical. We are able to read from something as complicated as a QFileSystemModel using the same AbstractItemModel API we got to know and love. And this is really cool. So let's close out of this, and we are going to try and use the same API to read from our standard item model tree model that we set up here. So let's comment out the code for file system model, and we will re-enable the code for standard item model. And we want to comment out this. This is already commented out. And we are going to go down and read from the standard item model. Let's put in the code to do that. It is really the same thing. So read from standard item model. And again, looking at this, try to guess what we are going to get printed if we use the same code we used here to manipulate the standard item model. Let's run, open application output, and we have our things here, and we have our tree on the left and our list with a single item to the right. So if we read from row 0, column 0 under the root item, we will get the item 0 text here printed out because it is the first thing in our tree model. So let's hit the read button and see if I am right. And you see it is the data here. And this is really cool. This is all I had to share in this lecture. I hope you found it interesting. And this is going to be the end of our overview of how you can separate things, having a view to display data and a model to store data. In the next lecture, we will try and look at an overview of how you read the data. And after that, we will see how you can build your own custom models from scratch. So go ahead and finish up here and meet me in the next lecture. In this lecture, we are going to try and recap on different ways we can access our data in our models and see the underlying structure of how models work. This is really kind of a review to try and put everything we know in perspective. And that's going to make us ready to dive into how you build your own models from scratch. Now, we have seen that the basic model structure is something like this. We have a root item. This item can have child tables, and each table is going to have a number of rows and columns. For example, the first table here, the first child table has n rows and n columns, and each element in this table can have its own child tables. For example, under row 0, column 1, we have a child table, which is this yellow guy here. Under row n, column 1, we have this blue table here. And under row 1, column n, we have this blue list here. Now, it doesn't really matter what kind of model you are dealing with, be it a list model, a table model, or a tree model. The underlying structure is going to be the same here. You can model a table model by just making the first child table here not have any more children. That's going to give you a table model that can model any number of rows and columns. But if you want, you can also model a list by doing something like this. This thing here is going to be a model. It's going to have a root item, and under that root item we're going to have a table that has a number of rows and a single column. So by this you can model a list, and this thing here is going to be a table. And if you zoom out and look at the entire structure we have here, you can model tree models. This is really cool. Here you see that we have representations for list model and a table model. This is just to give you a chance to really look at this in a much cleaner way. And we know that we can use model indexes to address items in our model to be able to read and do things with the data contained in those model indexes. If we need to get an index to an item, we have to go through the model. So we can tell our model, please give me the index of the element at row 0, column 0 under this parent model index. And you get to the root index by calling the default constructor for QModelIndex. This is something we talked about. And using this, we can really address any item in the model, provided we know the row number, the column number, and the parent under which it lives. And we can keep hunting from parents until we hit the root item in our model. This is something we can do. Now, a model index is really a pointer to a piece of data in the model. This is how I would like you to think about it. And we have the ability to check and see if a model is valid. We can do that by calling the isValid method on our QModelIndex object. If this returns true, that model index is going to be pointing to a real piece of data in our model. If this method returns false, the meaning is that the QModelIndex pointer is going to be pointing to the root item. And this is really key. Now we have the ability to be able to ask an index, are you the root item, by calling this method here. If it's a root item, we may do something. If it is not a root item, we may do something else. For example, if you intend to read from a model index, it is actually a good test to test and see if the model index is valid. If it's valid, it's going to be pointing to real data, and you can read data from it and do things with the data. But if you get that it is invalid, it is the root item, and it is really not meant to be pointing to any data. So reading from the root index is really disastrous, and it is going to cause problems for your Qt application. Now you can get a root index by calling the default constructor like we already know. So let's look at a few of the methods we have in the QModelIndex class. We have the column. We can ask the index which column it is referencing the model. We can ask the row. We can ask the model index to give us its parent through this method here. We can get the data. We already know this. And we just learned that we can ask a model index if it is valid or not. Another thing you can ask a model index is which model it belongs to. You can use this method here to get the model to which this model index is belonging to. And all these methods are going to come in handy sometimes as you are using these things here in your career as a Qt developer. Now, how do we get a model index to work with in our C++ program? Well, you can ask your model the index of a given element. And when you ask for the index, you have to give the row, the column, and the model index of the parent for the item you want to get the index for. And if you don't know the index for the parent, then you can keep going up, up, up until you hit the root index, and you're going to be to the top of your model, if I can say it like that. A few things I would like you to know is even if we are dealing with a list, table, or tree structure, we still need to think in terms of trees when reading data. The reason is that we still need the parent item if we really need to use the QModelIndex API. So when you need a pointer to an element in the model, you have to specify the row, the column, and the parent. And it is because we need this parent item that we still need to think in terms of trees when reading data from our models. Another thing you should know is that QModel indexes are meant to be retrieved and used. Once you are done using them, you have to throw them away, because if the model changes, the model index may be pointing to something else. So suppose we have a list of items here. I'm going to do a little list to really make this point here, okay? And we have a model index pointing to item number 3. Let's say we have a 1 in here, and a 2, and a 3, if I can write with my mouse. And this is a list of things, for example, and we have a model index pointing to this 3. Now, suppose we insert a new item here. Okay, the 3 here is going to go down and become a 3 here. Okay, the 3 is going to move down, and for example, we inserted a 7 here. Now, the model index is going to keep pointing to this location, even if the element we really wanted to point to has been moved to another location. That's why once you are done using a model index, you should really throw it away. And when you need to get a new model index, then hunt for the element you want to get, and then have a real model index to work with that element. That's really what I am trying to mean in these points here. Now, if you want to have a model index that follows your elements as they move through the data structure, then you can use QPersistentModel index. But as you might have thought, QPersistentModel index is a bit expensive to use because you have to keep state, you have to have the logic to follow the element as it moves around. So make sure you use this only when you need it. And in most cases, QModel index is going to be enough. A good use case for persistent model index is to follow selected elements in your list or tables or trees. Suppose you have an element and it is selected, it is the currently selected element, but you want it to still be selected even if you add new elements. So you can use QPersistentModel index to make sure the index you have is pointing to the currently selected element. Even if it happens to move around, that's still the element you want to be selected in your Qt application. Another thing we had a chance to talk about is the concept of rows, and this allows us to read different pieces of data from a model. And here we have a screenshot from the Qt documentation really explaining this. We might read data from our model using the data method, and this value we get can contain multiple pieces of data at any given moment. For example, it contains the text that is displayed through the display role. It may contain the decoration role, which is going to be the color here, for example, or a pixmap to represent something. It may contain tooltips and all kinds of crazy things. So roles are a way we have to read different pieces of data from the data we read from the model, if that is making any sense. We also had a chance to learn about a bunch of roles we can use as we moved through the chapter here. And now that we know this, I want to unify different ways we have seen to read data through our models or model view architecture applications that we have been doing throughout this chapter here. If you are working through the QAbstractItemModel API, you can call the data method directly on your model. And once you have the data, you will have a Q variant through which you can read things from. You can also use the data method on a QModel index, and we had a chance to look at how you can get this to work. But another thing we have seen is that we still have the data method even when using convenience widgets like QList widget, QTable widget, and a QTree widget. We even had this method on QStandardItem. And this probably is a good hint that even those convenience widgets are working with QAbstractItem models under the hood. And this is really all I wanted you to see. It was kind of a review of what we have seen, learning about the structure, learning about the underlying, reviewing the underlying structure of our models, and then building on top of that to understand how we read data through the data method. Again, reading data is really simple. All you have to do is call the data method, give the index you want to read the data for, and pass the role. And the roles are really what we have here. A role can be a display role, decoration role, or whatever. And please make sure you use this to your advantage as you progress in your career as a C++ Qt developer. We are stopping here in this lecture, and I will see you in the next one. In this lecture, we want to start and see how you can build your own custom model. Up to this point in the chapter, we had a chance to look at different ways you work with models in your C++ applications using Qt. For example, you can use built-in view widgets like QList widget, QTable widget, and Qtree widget. You can use pre-built models and plug these models into pre-built views. For example, you can use QStringListModel, QFileSystemModel, QStandardItemModel, and we have seen that you can plug these into different views, and that worked out pretty well. And starting in this lecture and going forward, we will see that it is possible to build your own without using the pre-built models, but even our own are going to be based on a few abstract classes that we get from the Qt framework. For example, if you want to build your own custom list model, it is not a good idea to build it from scratch yourself. You can subclass QAbstractListModel, and this is going to give you the blueprint code on top of which you can really build your own features relatively easily. Following the same idea, you can subclass QAbstractTableModel to build the table model without having to build everything from scratch yourself. Now, if you find that tables and lists don't work exactly like you want, you can go ahead and build your own full-scale model built on top of QAbstractItemModel. And these are the base classes we have to really give us a way to plug into things that the Qt framework has built for us. Now, QAbstractItemModel is an infrastructure we have in Qt to allow us to define the underlying structure of our model. For example, we can specify how many rows a model has, how many columns, how many nested levels of items we have in the model. We can really do all these things. We can also define the content or the data available at each model index in the model. And as you already know, QModel_index is going to be addressing each item in the model. Through the API provided by QAbstractItemModel, we can also send notifications when things change in the model. We can forward changes from views and put those in the model. And there are a lot of virtual functions we can override to really do all kinds of crazy things through our models. And we're going to have a chance to override some of these, I think, starting from the next lecture. Now, the same structure we have been talking about since the start of the chapter applies. Our list models are going to be modeled like this, our table models are going to be modeled like this, and our tree models are going to be modeled like this. And even if you happen to be dealing with a list or a table model, you still need to think in terms of trees. You basically have to have this kind of image in your mind, because when you use the model index API, you need to think about the parent of the item for which you want to read the data from. So for example, if we wanted to address this item here, we could say it lives at row 1, column 0 under the root item here. If you want to address this item here, for example, you need to say it lives at row 1, column 2 under which parent? The parent happens to be this guy, which itself is living at row n, column 1 under the root. You really need to think in terms of this. Okay, now that we know these things, let's go to the Qt Creator IDE and look at the QAbstractItemModel class. Okay, we can look it up here and we click on more. But before we even click on more, you can see this class is going to be inheriting QObject. I think this is a good thing to look at here. And you can see a bunch of classes that inherit from this. Let's see if we can recognize some of those classes. We can see QAbstractListModel. I think we should also have QAbstractTableModel. It is right here. And you can see proxy models and all kinds of crazy things. And you can even see QStandardItemModel. They all inherit from this QAbstractItemModel class. And from this, you can see that we are really moving up into working in more abstract ways, going down to really implement things on our own. And this is much deeper than what we had done before by using convenience widgets like QListWidget, or even having pre-built models that we plug into existing view classes like we have been doing in the last few lectures. Let's click on more here, and we see that this class defines the starter interface that item models must use to be able to interoperate with other components in the model view architecture. So if you want to communicate with other things into the model view architecture, and you really want to be a model, or you want to store data, you need to speak the language spoken by QAbstractItemModel, if I can put it like that. Let's go down and see a few other things we can talk about. You see, they try and talk about the model index API here. So this thing is going to be living at this row and this column. And we need to think about the parent of this item. So we may think that the parent is going to be something like this. Okay, I do recommend you really take some time to read this documentation here. It may be intimidating at first, but take a moment to really go through this at least once or twice. One thing I want you to see is that we have a bunch of virtual methods in the API for QAbstractItemModel. So for example, if we go here, we see that canDropMyMedata is virtual. We see that we have a virtual destructor because we want this to behave well with polymorphism. And we can see that we have a data method through which we can return the data that our model is wrapping around. We will have a chance to play with us. The idea I want you to get is that you will have chances to override any of these virtual methods to define how your model is going to behave, and that's going to be really cool. Take a moment and see all these virtual methods, and they are your chances to customize how the model is going to work to suit your own needs. Okay, this is really the idea I wanted to drive home in this lecture. Having a basic understanding of QAbstractItemModel, you have a bunch of overrides you can override to really make the model work according to your own need. But there are many of these overrides, and sometimes you don't want to go that deep if you want to do something simple. That's why we have a bunch of classes we can use. For example, if you need a list, you can subclass QAbstractListModel. If you need a table, you can subclass QAbstractTableModel and be on your merry way and only have to implement things that you need at the table level in your QAbstractItemModel inheritance hierarchy, if I can say it like that. Okay, now that we know this, we're going to head over to the next lecture and start building our own custom table model. And as you might have guessed, we are going to be subclassing QAbstractTableModel. In this lecture, we will see how we can build our own custom table using the QAbstractItemModel API. And our model is really meant to be fed into a table view, which is going to display the data in a way that is relatively similar to this. We will have the first name, the last name, the age, the profession, all the way to favorite color here. And we will see how we can display this data by plugging our model into a table view. Now, the model is going to be following the same structure we have been talking about all along. So we will have a root item. The root item is going to have a child table, but for list, the child table is only going to have one column and a bunch of rows. For tables, the child table is going to have any number of rows or columns, but things into this child table are not allowed to have further children because we are really interested in this single table here. That's the only thing that makes sense for tables. If you want trees, you need to go full scale and allow children at any level to have children. And any view that is capable of handling trees is going to be able to navigate through all this madness to be able to display data in a tree view. Now, to play with this, we will set up our own class. We will call it Custom Table Model. How creative. This is going to be inheriting QAbstractTableModel. And some of you must be asking, why aren't we inheriting from QAbstractItemModel? Yes, you can do that and really achieve the same thing we are doing here. But QAbstractTableModel already takes care of the underlying infrastructure to set up a model. And it only leaves things that pertain to tables for us to implement. And what that means is that we will have fewer virtual methods to implement to get what we want as fast as possible. That's why we are inheriting from QAbstractTableModel here. Now, our model is going to be wrapping around a 2D data structure, which is really going to be a table. And to play things simple, we are going to do a 2D nested vector. Okay, it's going to be a vector of strings. And this may not make sense to many at this point, but let's look at how we can populate it with data. So this is how we do this. We are basically going to say our table, which is a vector of string, and we are going to append a vector of string that we initializing using curly braces like we have here. This is going to create our list of strings and append that into the vector of vectors of strings. So take some moment to re-understand what is going on here, and you will going to understand. If you still don't understand, you can ask me and I will do the best I can to help you out. Now, at this point, we are going to put this code in the constructor of our model. And once we create an instance of the model, the data is going to be available for us to consume already. Now, what we need to do is to provide virtual methods that would allow our model here to communicate within the infrastructure provided by the model view architecture in Qt. And there are a few methods we need to do. We need to specify how many rows our model has. We do that by overriding the row count method. We need to specify how many columns we have in our model. We do that by overlaying. We need to specify how many columns our model has. We do that through the column count method. And notice that this is going to take an index. So the caller of this method will need to provide an index for which they need to know the column count. And you're going to see how we handle this in a minute. And another thing you should know is that what they give us is a parent. So in other words, the question is going to be how many rows do we have under this parent in your model? Okay, if we are given the root index here, the question is going to be how many rows do we have under this root? And we are going to count 1, 2, 3, all the way to n, and we are going to return we have n rows from that method there. The column count method is going to work in the same way, so we will get the root item, okay, as a parameter to the column count method, and the question is going to be how many columns do you have? And we are going to count from 0 to n. And we're going to say that we have however many columns we have in this thing here. The same idea applies. So if we are given this index, we will go down and say we have 10 rows under this parent, if that happens to be the case. I really hope this makes sense. Okay, another thing we have is the data method. So the caller of this method is going to provide an index and a role, and we need to return whatever data we have at this index in our model. We also have header data, which is going to allow us to specify the headers for things in our model when it gets to be displayed in a table view. You're going to see how this works in a minute. Okay, here is the implementation for row count, and some of you must be asking, Daniel, I do understand why you return table size here. Okay, here is the implementation for row count and column count, and this is going to need some explanation. The first thing we do is to check and see if we have a valid index. And if you remember, let's draw this to really make this super clear. So suppose we have a table like this, or the first level table in our model, and we have root sitting on top here, okay? If we take a root model index and a call is valid on it, it is going to return false if you already know that. So this is just a way to check and see if we are either dealing with the root item or any other item in the table here. So if this doesn't return, so the question we are really asking here is if the parent of the item we are interested in is root. And if the parent happens to be root, we are going to know that this is our first level table, and we will return the data we have. So row is going to be however many things we have in our table. And again, to make sense of this, let's go where we append things in the table. So the first thing we append here is going to be the first row. This is the second row. And please note that these things are going to be indexed from 0. So this is going to be 0, 1, 2, all the way to the end. And we are going to have however many rows we have added here. That's why we are calling the size method on table to get the number of rows in our table here. Okay, now I think you have an idea about why we are doing everything we are doing here. Okay, now I think you have an idea about why we are doing what we are doing here. And if the condition here fails, we are going to return 0, meaning that we have no business really returning data at that location because we don't really care about that. We only care about the first level table in our table view. That's the data we want to display here. The same idea applies to column count here. So we check and see if we are dealing with a first level item. If it is the case, we will return the number of items. Okay, if it is a first level item, we are going to return the number of items we have within each row, and we are just going to choose the first row here. It is going to do, and we're going to return that. Again, if the condition here fails, we're going to return 0. Okay, we have talked about row count and column count. Let's talk about data. This is the method that is going to be called to return data. And we know that we get the data to display through the display role. We have had a chance to work with the Qt display role a lot of times. So what we do, we get the data at a given index in our table. So we say at index row, at index column, because this is an index. And you know the index class has row and column methods we can use to ask the row and the column that are stored in that index. I know this is a bit convoluted, but this is what you have to do to get this to work. So if we have a display role, we will return the data in our table, but we also want to control how things are displayed in our table, especially if we are dealing with colors. Our model is also going to be modeling favorite colors in one column. So we are going to put that in the 6th column in our model. And if the caller of this method happens to be looking for the decoration role, and we are dealing with the column 6, we will return the color to be used for decoration purposes in views that are using this model here. I really hope that makes sense. Now, if neither of these conditions apply, we are going to return an empty Q variant, and this is the syntax we use to do that. And the next thing we want to look at before we head over to Qt Creator is the header data method. And it is just going to specify headers for our model. So if we are working in horizontal, so if we want to display horizontal headers and we are dealing with the display role, we will return things pertaining to each section we are dealing with. So if the section is 0, that's going to be first name. If the section is 1, it's going to be last name. And we will go until we hit favorite color here. I know some of these things may not make sense yet, but once we go to Qt Creator and start playing with us, and you will understand how everything works. Now, once we have the model done, we will create an instance of it in our widget, and that's what we do here. We create an instance of the model, so we will do that right here and give it a parent. We will apply it to a bunch of views like we do here, and if we run, we will have something like this. And this is going to be a model we completely built from scratch, basing our work. And this is going to be a custom model we built ourselves, building on top of the API provided by the QAbstractItemModel API. So let's head over to Qt Creator and do this. Okay, here we are in Qt Creator. Let's create a new project for our thing here. It's going to be a widgets application. We are going to give it a name and store it somewhere on our drive. Let's hit next. It's a CMake project. It's going to be based off QWidget here. And we hit next and choose the kit. And we don't want the version control system here. So let's finish. This is going to generate our project here. So we want to go to the UI form and set up a bunch of things we can play with. That's going to be a list view. Let's do that. List view. We also want a table view and we want a tree view. Okay, let's select that and align these guys. What we have on the left is a list. What we have in the middle is a table. What we have to the right is a tree. So what do we do here? We can add a bunch of labels to make sure we see the data correctly. So let's say label, and we are going to say label here, another and another one. And we want to say list and a table and a tree. And we want to align these guys a little bit. So what do we do here? We can use a bunch of spacers to make sure this looks as good as we want it. So we're going to put in a bunch of spacers here. And we need another pair of spacers, horizontal, and another pair. And we will need to lay these guys out. Let's use horizontal layout here to lay them out like this. And now we can apply a vertical layout to the entire thing. Let's make sure on the left we have the list view, in the middle we have the table view, on the right we have a tree view, And we also want to put these guys in a horizontal layout before we apply a vertical layout to the entire thing. Sorry, my bad. Now you see that we have a list on top of the list, we have table on top of the table, and we have tree on top of the tree. And if we run, this is going to look much better. Okay, this is what we have here. Now we want to create our class, and we will create a new class here. Let's go to the folder where we have everything and right click and add new. It's going to be a Cplusplus class, that's what we want. And it's going to be custom table model. I think that's what we said before. And the parent is going to be custom, and that's going to be QAbstractItemModel. I think we have that right here. And we are going to create it, hit next. We don't want to add this to Git, and we want to finish. And let's copy the files and put them in our cmake_list.txt file here. And that's going to be custom model, header, and CPP file. Let's run cmake again on the project to make sure we see our files, and we have the starting point for our model here. Okay, we are subclassing QAbstractItemModel to only be able to implement things that are useful for tables. And we don't want to really do the underlying structure to build a model from scratch, like we would do if we had to subclass QAbstractItemModel. Oh, we subclassed QAbstractItemModel. We don't want that. We want QAbstractTableModel. Sorry for this. So we are doing a table here. So let's do table model. And we need to change this in the CPP file. Let's say QAbstractTableModel. I think this is going to do. Let's see, what did we do wrong? Let's go back, switch to header, and copy the code for table model. Oh, we need to include QAbstractTableModel. Let's paste that in here. I think we have that on the clipboard, and we need to go down here and change that as well. Now this should be happy. Okay, so we have our custom table model, but what we want is for this to wrap around our vectors of strings. So what we will do is create a private section and put in our vector of strings. We're going to call this table our member here, and we need to go to the constructor and populate the table with data. So let's do that. We will paste in the code, and I really recommend taking the code here and copying and pasting this. You can get the code from GitHub. I am going to share the link to the repository, and you don't really have to type this unless you want to. And take a moment at the data we have here. We have a last name, a first name, an age, a profession, marital status, the city. I think this is a city. And we have the favorite color. And in total, we have 1, 2, 3, 4, 5, 6, 7 columns. And these are going to be indexed from 0 all the way to 6. These are a few things you need to be aware of. Now, we need to override a bunch of methods to make this a real table that can communicate within the model view architecture of Qt. So what we need to do is to put in the overrides we talked about in the slides. And Qt provides an easy way you can do that. You right click on the class name. Again, make sure this guy is selected. Right click, go to refactor, and choose insert virtual functions of base classes. Let's click this. And if you browse through this, you will see that there are a bunch of methods that are already checked. We have row count, we have column count, we have data, okay? We also want to put in a bunch of headers, but what is required is really these 3 methods. And if you only have these 3 overrides that are checked, your model is going to work. If you go down, you see that we have a bunch of them, but these are the required ones. But we also need to work with header data. So let's do that. We're going to check header data here. And these are going to be our 4 methods. If you go down, you will have a bunch of options here. For example, insert the definitions in implementation file. This looks like what we want. The implementations are going to go in the CPP file. Add virtual to function declaration, add override equivalent to function declaration. We don't want any of these. The defaults are okay. And we are going to have our methods here. One thing I don't like is that Qt creator is going to put these guys below our private section here, and I don't like this. So let's put this back in the public scope of the class, and we will keep this comment here to mean that we are implementing the abstract item model interface, And if we go in the CPP file, we see that we have a bunch of methods generated for us, and we will use this as a starting point. So Qt Creator is going to help you out here. Now, what do we want to do in row count? If you remember, we need to ask if the parent index isn't root. Now we need to implement these methods. And if you remember, we only want to return a valid piece of data or actual data if our parent is root, okay? So, and our parent is going to be root if the parent isn't valid. So we're going to write a piece of code here. We're going to say if not parent is valid, okay? We're going to return a piece of data. Otherwise, we're not going to return anything. So we're going to return 0 as the row count, saying that we have no row at that index, if I can say it like that. If we happen to want to return data, we will need to return the data from the table here. Now, if we fall in here, we need to return how many rows our application has, and that's going to be the number of rows that we have appended here. So that's going to be return table size. Okay, this is going to be our row count. Okay, now we want to do the column count method, and we're going to steal the same ideas, but we will be returning the column count in this case. So we don't want to return anything if our parent isn't root. So we are going to return 0 if parent isn't root. But if we fall in here, we don't want to return anything if parent isn't root. So if parent isn't root, we will return 0 as the column count. But if we happen to have root as our parent, we want to return our column count. And if we count here, we see 1, 2, 3, 4, 5, 6, 7. So we have 7 columns, but we can't say that and hard code the 7 in our code here. If we did, it would work, but it is really bad design here. We need to return the actual number of items in the table by asking the table itself. So we can tell the table, whichever thing is at your first row, we want to grab how many elements we have inside. And we can do that by saying table at 0. We're just going to grab the first thing here. So table at 0 and size. Because our vector is a vector of vectors of strings, if you remember that. So this is the code you want to use here. Now we are going to hit the data method, and this is the method that is going to be called when views want to display the actual data that we have in our thing. When views want to display things we have in our model. You see, we are given an index and we are given a role. So we need to return the data that lives at this index in our table and respect the role here. So we need to check to see the role that is given to us before we do that. Because if you remember, we have a bunch of roles. We have display role, we have decoration role, and we have all kinds of crazy roles we can play with in Qt. So we are going to say if role equals Qt display role. Okay, we can do that. We are going to return the data in our table at a given row and column. And we do that by saying table, because we have access to this table here. And we want something at a given row, and the row is going to be from the index. So we're going to say index row. And we want to add again with the column from the index. So we're going to say index column. And that's what we're going to return here. I think this is going to do. And if we fall here, we are going to return an empty Q variant. You can either say return Q variant. Okay, you can do something like this. Another way you see these days is to use an empty pair of curlies, and that's going to return an empty Q variant. It is just different syntaxes to do the same thing in C++, and that's what I'm going to use here. Now, let's go to header data. You see that for header data, we have a section, the orientation, and the role. And we only want to handle the display role because we want to just display data. We only want to respond if the orientation is horizontal. So I am going to go down here and put in the code because I don't really want to waste your time watching me type this. It is a long piece of code. And if we want, we can break these guys on separate lines so that you see what is happening. And we are checking for the orientation. And if the role is the display role, we're going to be checking for the section and returning something pertaining to that section. For 0, we are storing in first names. For 1, we are storing in last names. For 2, we are storing in ages. And that's what we are really saying in this header data method. If section is 0, the header is going to be first name. If section is 1, the header is going to be last name. If section is 2, the header is going to be age all the way to 6, which is going to have favorite color as the header. And believe it or not, now we have a model that we can use in our C++ program, and this is really cool. So take a moment to look at the documentation for these overrides, see what they do, play with them, and you're going to really see that it is not that hard to set these things up. Now let's go to our header for widget, and we will include our model and use it like we have used other models. We're going to say custom model, custom table model. And we want to create an instance of that custom table model, and we will have a pointer model, and we will create an instance of that in the CPP file. So let's say custom model. No, let's not say that. We're going to say model and say new Q custom table model, and we want to give this a parent, and we want to say UI list view set model, and we want to pass our model, and we want to say UI list table view set model. We want the model here, and we want to say UI tree view set model. We want our model here. Okay, let's see how this works out. We know that we have a table model, so a list view shouldn't be able to display this, but we're going to see what happens. I want you to see that we expect this to work perfectly with our table view because we have a table model, and we expect this to work relatively well with trees because a tree is really more advanced than a table. So a tree should really handle a table model relatively well. That's the guess I am trying to make here. Let's compile and see if our code actually compiles, if we have no boo-boos in. And we're going to wait for compilation to finish. It is done. Compilation is good. And if we run, we see that we have no data in our thing here. So what is going on? Let's look at our model. I think we must have something wrong in the model. Let's see our data method. Looking at our data method, you see we are saying table at whatever, but we are not returning here. So let's do return the actual data to be displayed. So let's return here and run again. Hopefully this is going to fix our problem because I think this is the problem. Now we have data in our list, table, and tree. And how cool is this? We are able to do this on our own, and we have a deeper understanding on how the model view architecture works. And one thing you should notice again, list is going to do the best it can. It's going to display one thing or one column of data in our model. The table is going to handle this well. You see we have a bunch of headers, and we have the data in here from first name all the way to favorite color. And the same is really available in our tree. Let's maximize this so that we have a better chance to see everything here. And this is really what you can do. And this is all you need to do to build a model on your own. Now, one thing we want to see is to handle the display role or the decoration role. And a chance we have to do this is to do this on the column that has color in it. So we want to decorate the things in this column using the color that is stored in here. How do we do that? We are going to check for the decoration role. Again, read the documentation to know what the decoration role does. What I am going to do here is check if role equals Qt decoration role. I just want you to have something nice to look at here. And index column equals 6, because that's the last column we have in here. We are going to fall over in here, and we are going to return a color that is going to be used to decorate the cell at this index here in our table view or tree view or whatever view is displaying the data here. So we are going to build the color from the text that we have in our table here. You see we have red, green, blue, whatever. The thing is, in Qt we can use these names to build the color objects that we can do things with. And that's what we're going to do here. We're going to return QColor. Okay, the color is going to be made up of whatever we have at a given row and a column from the index that we have here. And we can even copy this. I think this is going to do. So let's grab this and save ourselves some typing time. and we are going to return this. We have to include the Q color for this to work, I think. That's the error I just saw. So let's include the Q color and go down and see if this actually works. You see, Qt Creator is happy. Now, if we run, I want you to scroll all the way to the favorite color column, and you're going to see that we have a bunch of squares with the colors that we have specified, and this is really cool. And this is really all I had to share in this lecture, showing you how to build your own model. If this doesn't make any sense, please watch the video a couple of times. If you still have problems, you can ask me, and I will do the best I can to help you out. We are going to stop here in this video, and I will see you in the next one. In this lecture, we want to see how we can make our own table model editable, or how to apply modifications to the table when the user wants to do that. Well, we want to build something like this, and it is going to be based on what we had in the last lecture. But to be able to handle modifications, we need to override a bunch of methods. And you might ask, how do I know this? I read the documentation, and I do still recommend reading the documentation on the model view architecture when you are done with this chapter here. So whenever a modification is needed in your model, the setData method is going to be needed. It is going to pass in an index, the value, and the role we want to set the data for. And the flags method that we override here is going to allow us to flag our model as a model that can be editable. So these are the two things we need to do on top of what we had from the last lecture. You already know these methods here. Let's see the implementation. The setData method is going to do something really simple. It is going to check the role, and we want to handle the edit role only if it is not the edit role, which specifies that you want to edit data. We are going to get out. We only want to do things if the caller of this method passes in the edit role. Now, once we know that we can edit, or if the role is the edit role, we will grab whatever piece of data we have at this row and column in our table and set it to the new value that we pass in here. Notice that we turn this to a string because our table is designed to store strings. And after this, we will emit a signal starting from this index and going all the way to this index that we have in the second position here. So this is basically going to say that the data has changed for a single index, but this gives you an idea that you can also pass a range of indexes here, if that makes sense for whatever it is you are doing. Now, once we do everything we need to do in here, we need to return true to mean that our job is done properly. If we can't do what we need to do, like we do here, we're going to return false. And the caller of this method may use these things to know whether we have successfully set the data in the model. And if you return true, you have successfully set the data in the model. If you return false, you haven't really been able to set the data in the model. The flags method is simply going to grab whatever flags we have on a QAbstractItemModel, and it is going to logic OR where QItem is editable. And what this says is that this model is flagged as a model that can be edited. I think we should have used QAbstractTableModel here. So we're going to change this when we hit code in a minute. Another thing we need to change is the data method, and we need to take into account the edit role when we return the data. And this is going to allow us to be able to grab the value at a given index in the model when the user wants to edit the value. I think this is really not going to be easy to talk about. So I will show you the effect of this when we get to run this in Qt Creator. And I really think it is time we headed over to Qt Creator and did this. Okay, here we are in Qt Creator. Let's create a new project. It's going to be a Qt widgets application as usual. This is going to be called Editable Custom Model. We're going to store this somewhere on the drive and hit next. I hope this name is not going to be long. If it is, we will cut it down. So we want QWidget here, and we are going to hit next. We want the kit to be MinGW, and we are going to hit next, and we don't want Git here. Okay, we have the project here. We can go to the UI form and really do what we did earlier, or we can steal all these files from the last lecture. I think we don't really have to build everything ourselves here. So what we're going to do is go to the previous project we did and go where it is stored on the drive here. I click on main CPP, show in Explorer. That's what I want. It's going to be opened up here. And I think I should steal everything here. Yeah, I should steal everything. So let's copy everything except for the CMake_list.txt file. So custom table model header and CPP, widget header CPP and UI file. And we will even grab the main file, but I don't think that's going to make a difference. So let's grab widget and the custom table model files. So let's grab these. I am going to close out of this. And I am going to go to my current project, which is editable custom model. Go where it is saved. So go to show in Explorer, and I am going to open this up here and paste in the files. It is going to say that some files are already available. I am going to replace them. And now the file widget UI has been changed on disk. Do you want to reload it? Yes, I want to reload everything. So let's close this here and close the main file. And we want to run CMake, and we will get a build error because we don't have a custom table model in our CMake_list.txt file. We can easily copy that from the last project. So let's copy and close here and go to our project and go to CMake_list.txt and put that in here. And I am showing you all these roundabouts I am doing here because you might need to do these things in practice as you build your own applications. Another thing I would like to do, let's see if I still have that thing opened, is to go up and delete the build file that might have been generated by Qt. Because we just changed things about the project, CMake might not like this, so let's save this and rerun CMake. And you see build files have been written to some location here. If we build, let's compile. Okay, it looks like this is working. And we have everything we had from the last lecture. So our project is ready to go, but this is another project separate from what we did in the last lecture so that you can really refer to any project you want. Now, what we want to do is to put in the setData method. Let's go to the header and do what we did before. Select the class name, refactor, and we are going to insert virtual functions. Now what we want is setData. So we're going to grab that and we want flags. And that's going to be this guy here. And once we have flags, and how do we see everything we've selected here? So we have setData and flags. That's going to be added here. So let's do OK. They are going to be put down here. Again, we are going to copy and move them over. So Control copy and modifications. That's what we want to do. And now we can take out this. And I think we have implementations in the CPP file generated because Qt Creator does that. The first thing we're going to do is flags because it is simpler. So we're going to return QAbstractTableModel flags. And we are going to logic OR this or bitwise OR this with Qt item is editable. I think this is the thing we have to pass in here. And Qt Creator doesn't, we need to pass in an index here. Okay, so this is going to be referencing a given index. So we need to pass the index we were given as a parameter here. And we don't need these parentheses. I am making a lot of mistakes. So we see Qt Creator is happy about this method. Now, if we want to set the data, we only want to set the data if the role is editable. So what do we do? Let's put these on separate lines. We will check the role and we will say if the role is not Qt editable or edit role, if I can say it like that, I think that's what is meant to be said here. And we want to return false. If we can't do anything useful here, we can do something like this. I think Qt Creator is confused here by my writing. So this is much better. Now, what we want to do once we know that we can edit is to set the data. So we're going to say table, and we are going to use the notation for 2D arrays. We will say index row, and index column. And you should know this if you know how to use vectors. So we want the parens here because we are calling a method, and we will change the data at this location. And what we pass is going to be value toString. Okay, this is going to be our code to change the data in a model. And after we do that, we will need to return true to mean that we have successfully changed the data in our model. And at this point, I think we should be able to edit items in our model. Let's run this to make sure we can do that. Okay, the code is here. If we change John to Daniel, notice that we are changing this from the list. Okay, and we're going to see the change applied in the other components. Okay, I don't know why it is taking time, but it should change. So let's change this to Steve. And when we need to manipulate things, the view is going to pick up change. I don't think we emitted the data changed signal. That's why it is not changing immediately. And this is a really good chance to show you that. I didn't plan on that. I had forgotten to emit that signal, but I am going to do that here. So let's say emit data changed from index all the way to index. I think this is going to notify views so that they can fetch data immediately without us having to click on a view to fetch the new data. Let's run again. Okay, we have the thing here. Let's maximize. If we change this to Daniel, we're going to see that it's going to change in the table and the view. If we change the last guy to Paula, okay, we're going to see this guy change and this guy change here. Let's do that. Paula. How cool is that? How cool is this? So let's go to the color and change to this to blue, for example. We're going to see that the color is going to change. And now we are really able to edit our model. And this is all we set out to do in this lecture. Please take a moment to read the code here. See if you understand what is happening. It is always a good idea to hit F1 on a method on which you don't know the information for. And you go in here and read about whatever method you want to read on. And the moment you do this, you will really start improving your skills to work with the Qt framework. I am going to stop here in this lecture and I will see you in the next one. Congratulations on hitting the end of this chapter where we were concerned with the model view architecture of the Qt framework. We saw that this was a way to separate concerns. We had a bunch of classes to store data, and we had a bunch of classes we could use to view data. And the logic of how these two things communicate was bundled into a delegate. And a delegate is a component that allows us to control how each single component is displayed within the view. Delegates are a bit advanced, and I would recommend checking out my intermediate course on Qt C++ GUI if you are interested, or you can even read the documentation and see if you can figure these things out on your own. One thing I want you to take out of this chapter here is the tree structure that models use to store things. And I had a chance to really stress this a lot in the chapter, but I want to say this one last time. Even if you are using lists, you will be using this tree structure under the hood, and you need to be aware of this every time you need to read an element, because you will specify the row number, the column number, and the parent under which that item is going to be living. And we saw that all this is wrapped into the QModel index class. We saw that the model view architecture could allow us to show data in different ways. We can do lists, tables, and trees. We could either do this using built-in view widgets like a QList widget, QTable widget, or a QTree widget. Another option was to use pre-built models and couple them with view classes. We saw that we could use QStringListModels coupled with QListView. We could use QFileSystemModel and use that with a tree view or a table view. We could do all kinds of crazy things. Now, if you want to build your own models, you don't really have to go down and build everything from scratch. You can subclass one of the available classes here, for example, QAbstractListModel or QAbstractTableModel. But if you are doing a tree model and going really deep and heavy, you can use QAbstractItemModel and build things on your own. And we saw an example of how we can set up our own model based on QAbstractTableModel and plug that into a bunch of views, and that was really cool. I hope this is a good introduction to model view programming in Qt. If you want to go deep and learn more things, I would recommend reading the documentation, or if you want another course, you can check out my intermediate course on Qt C++ GUI, and you will learn much more about the model view architecture in the Qt framework. I am going to stop here in this lecture, and I will see you next time.